So hello friends, welcome to my channel MN Coaching Center. So today let us discuss the 12th, the most important exam after 12th, or the most important competitive exams that you are facing after 12th, that will decide to which college you are going. That exam marks will decide which college you will go. So these are three exams are very much important. Four exams you can say. Then JE and JE advanced is also there. So you can say these four. It is four only. So these four exams, three or four you can say. So let us take four. So these four exams, it is most important for your life. It will be a deciding situation for you. So let us see. So for that you need some preparation. So before going to the preparation, what I am teaching you for that is important for that exam, the things what I am going to teach you for that exam, first let us know. We will know what is CET, Neet, J or J advanced, what it is, and for how much marks, for what is the duration of that exam, and many more information of that exam. Let us know first, then we will start with the questions, important questions, or the questions from the chapter. As you know, in every exam, the basic thing you will know is in every exam they will ask you the questions from the chapters only, what you have learned. They may ask from your 11th standard chapter and also from 12th. So 50% of the question is asked from your whether it may be any exam, means whether it may be in this competitive exams, whether it may be Neet, JEE, CET, JEE Advanced. In any of these three, they will ask you the questions from your textbook, and also they will ask the questions from your 11th and 12th. What 50% of the question is from your 11th chapters, whether it may 11th chapters, whether it may be in any topic, any subjects, like it may be in chemistry, physics, bio, or maths, like that. If you take any of these, in this they will take 50% of the chapter from your 50% of the questions is asked from your 11th chapters, what you already have had in your 11th chapters in these subjects, and another 50 from your 12th chapters. This is the basic information that you all should be knowing. You may be knowing, your teachers have been said about this. Now, now let us come to the important information about the exams like CET Neet. So the CET Neet, important is that, so important information is how, for if you want to go to any of the colleges, the marks that is given to you will be like this. They will take 50% of the marks from your 12th. If you how much marks you like, see, if you scored 90% in your 12th, they will put 45% of the marks here, means 45%, 50% means they will put how much, 50% of marks they will put for here, and then what the marks, what ranking you have got in your Neet, CET, JEE, what you have taken, in that how much marks you get, they will, in how much marks you will get, that much marks they will put here, and they will give you a percentage. Yes, so they will give you a percentage. So therefore the 50% is taken from your 12th and 50% is taken from your Neet, CET or JEE. like this. For any course you are going, they will take like this. Whether after 12th you are going to after 12th you are going to go to engineer or medical or any other branches, so they will take marks like this only, and they will give you the marks, total marks, so that you can join the college, which college you may join to know. And now if we come to the Neet, first let us know about the Neet. So now we are learning first basics, so let us start the basics. So first let us know little basics, after that we will start the questions of the chapter. So first, for Neet, the question paper, the marks will be 720 marks total also 720 marks. So 1 mark will be deducted for one wrong question if you give wrong answer for that question, and 4 marks is given. You will get 4 marks if you get one correct answer. So it's not that much easy for getting answers in the Neet. So before writing any of the answers, you should think once. As you know, the duration for in that in the next is they are given 180 questions are there in the CD. You can say means questions they are 180, but marks is 720. Okay, so in that the time they have given is 3 hours. Okay, 3 hours time they have given. So think like that, you have 1 minute for one question. So think wisely, think fastly, and write the answers. Don't be very slow, means don't do any wrong. As one, you will get, if you correct means you will get 4 marks, but if it is wrong, you will 1 mark will be minus. So before getting that minus mark, before doing any mistake, you think, you see the question first. Do like this, 10 seconds, see the questions, then see the answers. Like if it is biology, chemistry, biology, physics they are given, then you can see the questions and you can answer it easily. So do answer for the biology and physics fastly. Fastly you should answer for biology and physics questions, as you need more time for maths and chemistry if there may be problems. So it is not easy, but some easy methods are there to solve. So that methods also we will learn in the question paper. So means I'll solve while I am telling you the questions, that time we will solve, but you should be fast in writing the answers. In 3 hours you should complete the paper, and you should not do more mistakes. Okay, so think correctly. Okay, this is about the Neet first. Now the next exam is CT. Okay, CT, the total marks for CT is 180. 180 is the total marks for CT. Okay, see here they have given 1 hour 20 minutes for you. Okay, questions you have they are not given, but duration is 1 hour 20 minutes for you to do the CT exam. Here you will get 1 marks for correct answer. For correct answer you will get 1 marks, but if you have a negative mark, here they will not deduct any marks. If you have done wrong also, they will put it wrong, but they will not do any minus. Okay, okay, this is CT. CT is easy, but Neet is little bit you should think. Okay, now JE. So JE is main, it is very much important. The total marks for JE main is 300. 300 is the total marks for JE main. For 300 marks, and 3 hour is the exam duration. So exam duration is 3 hour. Okay, 3 hour is the exam duration, and 2 parts is there for doing the JE exam. First one is computer based, so they will do on computer based exam. The first one where the marks is 300 and the time they given for you is for 3 hours, but for here they have not given any information about how much mark will be deducted or how much mark will be given for correct or wrong answers. And in the second part of JEE exam, that is computer pencil exam, so it will 400 marks it is, and you will be given duration as 3 hours. Okay, so this is about JEE, Neet, CT basics informations I am telling you about these exams. Okay, now you learned, you know what all the basics information you want about these exams. Now you learned. Now let us come to the thermodynamics. So first material that I am using and that I am telling you, I am giving the questions that may asked from the chapter is, see, thermodynamics is the first chapter where I am asking you the questions I will give. See, in 12th thermodynamics, that is chemistry, thermodynamics below comes under chemistry. So now let us know some of the basics informations about thermodynamics, and then we'll start about with the questions, material questions. So first we'll solve the 100 questions. Okay, what all the means questions I will say you. See, first we will the 100 questions will they are there in thermodynamics I am giving, that we will solve. Means we will not solve, we will see first. See, now let us know the basics of thermodynamics, then we will start with questions. So first law of thermodynamics, first let us know. So what is thermodynamics? First let us know. Thermodynamics, it is the study of energy transformation and relation of matter. So thermodynamics, it is the subject topic where we study the energy and energy transformation and relations of matter. In these topics we will learn in the thermodynamics chapter. And in that, the first law of thermodynamics is, there are 3 laws in thermodynamics. First law is energy can neither be created and nor be destroyed. The second law is the entropy of an isolated system, not equilibrium, will tend to increase over time. It will be increased over time. And then the third law that you are going to learn in thermodynamics is, as temperature approaches absolutely zero, when temperature approaches to zero, the entropy of a system approaches a constant minimum. So the as temperature of any object, if anything, if it approaches to zero, if it comes to zero, then the entropy of an substances, it will become a constant minimum. It will be the minimum what we will get is the with the temperature it will be. Now questions on thermodynamics in material. First, thermodynamic states. The first question we are learning in the first topics from which we are getting the question is thermodynamics state. So what is thermodynamic state means? The a thermodynamic state of a system, it is its conditions at a specific time. So a thermodynamic state is what is its condition at a specific time. At a specific time, what is the conditions for it, you will know in this thermodynamic states. Dynamic state. Okay, so fully identified by values of a suitable set of parameters. So it is fully identified by values of a suitable set of parameters. By values of a suitable set of parameters, you will know that what is the temperature of no suitable set of so fully you will identify the values of a suitable set of parameters which is known as a state variables. So therefore these state variables, it is also known as thermodynamic variables. Will also know the parameters that you get, it is also known as state variables or state parameters, or also you can know it as thermodynamic variables. Okay, now first question of your in this thermodynamic state topic, the first question that you are going to learn is the first question that you are going to learn in this thermodynamic state is, so the question, let us come to the question. So first question is, so when the system does not exchange heat with the surrounding, the process is called as. So in thermodynamic process you learned some things. So in that topics, so I gave you their only basic information, but many more topics you learned in this thermodynamic states. So in that, the first question they asked is, when a system when it does not exchange, when that system it does not exchange heat with its surrounding, when the system does not exchange its heat with the surrounding, the things that are available in surrounding, if it does not exchange the heat, this process, what it is called, this process is called as this process is called as, what this process is called, let us know now. So the answer is, the process is called as adiabatic process. Okay, so the in contrast, an adiabatic process is where a system does not exchange, it exchanges no heat with its surroundings, so it does not exchange any heat with its surroundings. So Q is equal to 0. Okay, so therefore question number 1 answer is adiabatic. So therefore here in the question they are given where the system does not exchange heat with the surroundings, the process is called as, it is called as adiabatic. So the option is B. Okay, this is the first question of the answer of first question of thermodynamics. So there will be easy questions and there will be more difficult questions also. So before seeing that, you have to answer it fastly. Okay, now so adiabatic process is the answer for first question. Now question number 2 is, so after now let us come to the question number 2. Now let us come to question number 2. So they are asked here, delta E is equal to Q plus W. So delta E is equal to Q plus W, it is the mathematical expression for which of the following? Here they asked the first law of thermodynamics, is it the mathematical form for first law of thermodynamics, or it is the mathematical form for second law of thermodynamics, or third or zeroth law of thermodynamics. So you also try to answer as I am going. You also try to answer for this question. So I will also tell the answers. You also try to answer the question. As I say the questions, I will give you some gap. Then you try to answer. Then afterwards, I will also tell the answer. So now, by seeing these questions, you may think and no, you may have said that you may have got an answer, conclusion. Now I will say that what is the answer for this question. So delta is equal to Q plus W is a mathematical expression for which of this first law or second law or third law or zeroth law of thermodynamics they have asked the question. So the answer is, so the first law of thermodynamics, it is the first law of thermodynamics expression that you learn is delta U is equal to Q minus W is the expression that you have learned for first law of thermodynamics. Okay, you have learned in the thermodynamics. So delta U is the change, or the delta U that you learn, it is the change in the internal energy of a system, and Q is the net heat transfer, and W is the net work done of or all the work on or by the system. Okay, so therefore delta U is equal to Q minus W. So therefore the answer is the first law. Here they have given delta E, delta U and delta E, they all comes to same. So for confusing you, they will change the some name, means they will give the similar name, like see delta Q or delta E you have learned in your thermodynamics while learning the first law expression, like that only. So how they will do means they will give you the first option. So they will not give you the first option, because delta Q, it is common, you will know, you will be easily knowing. So for confusing you, they will give delta E, so that you may get confused. So think correctly. Okay, think on both the options. So means think or slash if they have given in any expression while you are reading, they keep in your mind both the questions, both the slash what they have given or what they have given. So think both the things in expression like that. They may have given delta E is equal to Q plus W, or you can write as delta U is equal to Q plus W, like that they may have given. So think, keep in your mind both, or also you should keep. They may ask anyone. Okay, so therefore the answer is now first law of thermodynamics is the answer. So okay, the answer you have got for your question number 2. So after getting the answer for your question number 2, now let us come to our next question. Means answer is delta U is equal to Q minus W. First the first law of thermodynamics, but second law of thermodynamics expression what it is. So delta S universe is equal to delta S system plus delta surrounding is equal to 0. It is the reversible process. In reversible process, the mathematical expression that you will get for second law is delta S universal is equal to delta S system plus delta S surrounding 0. So this is the option B. They have given no option B, that is the second law. So this expression that comes in second law, but this expression is not given in the question. They have given first expression, so option B is wrong. Okay, that will not come. And option C, third law of thermodynamics, they have given delta U S is equal to 0. So therefore this also they have not given in the question. They have given delta E is equal to Q plus W or Q minus W they have given, or Q plus W or Q minus W. Okay, and zeroth law, it is T1, T2 and T3, or they can be written as T1 is equal to T3 and T2 is equal to T3 and T1 is equal to T2, like this it can be written. So therefore this option this all they have not given. So therefore option D, that is zeroth law of thermodynamics, it is also wrong. So therefore the answer is third. The answer is first law of thermodynamics. So delta E is equal to Q plus W. It is a mathematical expression for the first law of thermodynamics. Now let us come to our next question, that is third question. Third question they have asked is system in which there is no exchange of matter, work or energy from surrounding is. So a system which has no exchange of matter or work, or it may be energy, whether any of these, that does not have any exchange from its surrounding, what it is called as. So whether it is called as closed or adiabatic or isolated or isothermal, which it may be. Think once you also. I will tell the answer in a few seconds. I will tell the answer, but before that you also think which it may be. Now so let us come to answer. So isolated, so therefore isolated is the answer. How means the expression for means the meaning of isolated is, the definition for isolated is the system in which neither energy nor matter can be exchanged with its surrounding. So this is the definition for isolated. And the question they asked is system in which there is no exchange of matter, work or energy from its surrounding. They have given. So therefore the answer is option C, isolated. Here they have given matter, work or energy, but here you have given only energy nor matter. It does not matter whether you have given 2 or 3. You should see whether they have in this 4 you should be. I am giving here answer explanation, but in final exam you should while seeing this question in your mind you should come that should come is these 4 explanation you should come. What is adiabatic definition you should know. You should come in your mind of seeing adiabatic, what is isolated, what is isothermal. Seeing the question immediately the answer means the definition should come in your mind. After that you should see the answer and you should take fastly. Okay, so think fast and keep in your mind. So you should be continuously reading the chapters. The way if you continuously read the chapter, that time only you will know the answers very easily. You will get the answers when you see the questions. If you not read keep continuously, or if you not read the chapters if you take after 1 week means if you read 1 week continuously and then if you leave, it will not go. Means it will not work for you in your final exam. Means in your Neet, JEE, CET, these exams you will not get good marks. Okay, so keep reading continuously. Now, so option C is the answer for question number 3. Okay, so therefore option C is the answer for question number 3. You got it? So I think you have got the question now. So this was some easy questions. In starting they will ask some easy questions. Step by step the questions will be little bit up, little bit difficult, little bit easy, little bit difficult, like that there will be. So you have to be reading, means you have to be keeping understanding, means think easily and give time for more means the questions that will be like sums, the questions that is in the form of sums, give the time for that more. And for easy questions that you will be no answer, think twice and write. Okay, don't, if you see here, if in your mind if it comes adiabatic suddenly, don't write adiabatic only, don't take the answer. Okay, first think one little bit, take small time, little bit time and think. Don't take more time, take small time and think which definition is this, in which definition, for which thing, in which options, means in this option for which it will be the definition. Think, then we will know what is the answer. What immediately in your mind comes, don't immediately write that. Okay, think for a minute. Okay, question number 3 is isolated answer. Now let us come to question number 4. This is also small question they have asked. So let us see this small question. So in the question number 4 they have asked, in thermodynamics which one of the following properties is not an intensive property? So in this question, in this thermodynamics, which one of the following properties that they have given below, that way maybe the pressure, temperature, volume, density, in this which one is not an intensive property they are asking. In these 4 options, which one is not an intensive property they are asking. So I am giving you a small time. In a second I will tell you the answers also. So I think you have got the answer. So okay, so therefore for this the volume is the correct answer, because the volume depends on quantity of the matter present in the system. See, in thermodynamics, intensive property it does not means intensive property, it does not depends on quantity of matter, which does the things that comes under intensity properties, the things that does not depends on quantity of matter. These things comes under this intensive property. But here the thing that comes under intensive property means the thing which does not have a quantity of matter. Okay, so here pressure, temperature and density, okay, it comes under this, because you cannot say what is the quantity of the matter or quantity of the temperature. You cannot say, you cannot change it. Okay, so but here in the volume you can change. So therefore the volume, this volume comes under does not comes under intensive property. So therefore option C, the volume, is the correct answers. Okay, so you should be knowing each and every definition, intensive property, what it is definition, and think which one comes under option. You should think, then you should go ahead. Okay, see here all of this does not have quality of matter, but volume have some quantity of, means this much quantity only you can put in volume, milliliter, liter, this much only you can put. But here in this intensive property you have to put this all. Pressure does not have the quantity, temperature, density does not have. So therefore this all comes under intensive property, but that which one does not, comes under intensive property is volume. Okay, this is the correct answer. Okay, now if you come to next question, let us come to next question after the question number 4. So the next question is for combustion of, see here they have given a big question, the sum, like it is a sum, so it is a big question little bit. So and also, but still it is like a question they have given that is like problems, like max problem, like this it is. So for this you should give more time. Okay, so keep time more for this, and for that like small questions they give less time for it. Okay, next is, see like here the question they are given is for combustion of 1 mole of benzene at 25 degrees Celsius. Like combustion of 1 mole of benzene at 25 degrees Celsius, the heat of the reaction at constant pressure is minus 780.9 calorie. Okay, what will be the heat of the reaction at constant volume? The formula also they have given, the equation also they have given, C6H6 liquid plus 7 of O2 that is gas gives C6CO2 that is gas, then change to they have given. So the question they have asked is for combustion of 1 mole of benzene, for combustion of the 1 mole of benzene at 25 degrees Celsius, in 25 degrees Celsius, the constant for this the constant pressure, that is the constant pressure is minus 780.9 calorie. What is the heat reaction? What is the constant value? What is the constant value you will get? They are asking. So the options they are given is C, minus 781.8 kilocalvin, or minus 780.80 kilocalvin, or plus 781.8 kilocalvin, or plus 780.0 kilocalvin. So in this, so now so this is like a problem, so I will solve directly. Let us solve, coming to the answer. So if we say solve the problem, see if we come to the problem, see the question they have given is, the reaction they have given is C6H6 that is liquid plus 7 1/2 O2 gas plus gives you So gives you 6CO2G plus 3H2OL. So delta Ng is equal to, it is the number of moles of gas products, the number of moles of gas product minus number of moles of gas reactants you have to do. So therefore delta Ng is equal to 6 minus 7 by 2 you have to do, because here 7 by 2 they have asked and here 6, so means here 6 they have given. So therefore 6 minus 7 by 2 you will get 6 to is that 12, so 12 minus 7 is equal to 5 by 2. So now next formula is delta H is equal to delta U plus delta Ng. What is the formula that you have learned in this thermodynamics chapter? So this formula you have to put. So therefore the given is, they have given temperature 25 degrees Celsius, that you have to convert into Kelvin for this sum. So therefore 25 plus 273 you will get 298 Kelvin. So therefore it is equal to 298 Kelvin temperature you have got, and or is equal to 2 calories K or mole, kilo per mole. Also you can say that is equal to 2 into 10 minus 3 calories kilo per mole. You have to take 2 into 10 to the power minus 3 in the questions you will learn in this formula. When you learn that while doing there was sum in that formula, there you will learn why it has come. You have learned, I think so. Revise it slightly, you will know. So delta U is equal to, you have to take these all things. So delta U is equal to minus 780.9 K. Okay, minus 780.9 K. What you will do means you will change the formula. Now delta U is equal to, you want delta U, leaving that you have delta H and delta Ng or T. You know you have these all things. So therefore delta U is equal to minus 780.9 kilo calories minus 5 by 2 into 2 into 10 to the power minus 3 into 298. These all minus 5 by 2 is your Ng, and in 2 into 10 to the power minus 3 is your R, and T is temperature, that is 298 Kelvin. So when you do all this you will get minus 782 kilocal. So therefore here 82 is not there, but that similar for that is minus 781.8 kilocal is the similar which comes near to it. So like that you have to take over the thing that comes similar near to it if you does not have option. Okay, so therefore the option means the answer is option A. Okay, option A is the answer for your fifth question. So this is a sum. So see, like this you have to do. This formula is the important, you have to remember, and how to calculate this temperature you have to remember, and how to calculate delta Ng and or how to calculate you have to remember. Then only will get the answers correct. Okay, so for these all the things you have to remember. Okay, for doing these sums like this if you get in your exam. Okay, so therefore the answer for fifth question is minus 181.8 kilocal. Okay, after this fifth question, after the question number 5, the question number 5, now let us come to question number 6. Okay, so question number 6, the question they have asked is, in an adiabatic expansion of ideal gas, in this adiabatic expansion of this ideal gas, the formula they are asking, which formula that comes. So W is equal to minus delta E will come, or W is equal to delta E will it come, will it be, or delta E is equal to 0 or W is equal to 0. What is the adiabatic expansion of ideal gas? So in an adiabatic expansion of ideal gas, heat is not exchanged by the system. So therefore in adiabatic, as you learned their explanation, the heat does not exchange by its surroundings. heat is not exchanged by the system does not exchange its heat with its surroundings. You learned in your adiabatic expansion, means adiabatic their explanation in this question number 2 or 3, I think so. There I gave you the explanation. So therefore here see, q is equal to 0, therefore q will be 0. Okay, so therefore what will you will get here, what you will get here they have said in adiabatic expansion of ideal gas, in ideal gas the heat is not exchanged, so q is equal to 0 it will be. So therefore delta E is equal to q plus W is the formula for the adiabatic expansion. So therefore q is equal to 0 means delta E is equal to E will be the answer. So therefore the correct answer is yes. So therefore the correct answer is will be the option B, because it has delta is W is equal to delta E. So they have reversed it. Okay, so for doing confusion they have reversed the answer. See here, sorry, wait. See here. So here see delta E is equal to W you have got. So they have reversed the, so that you may get a small confusion. So you may get confused. So for don't get confused, think slowly. As you know the topics, think topics, don't go deeply. Okay, what you know put fastly and finish it. Okay, that's all. Okay, so therefore the sixth one, the answer, the question is in an adiabatic expansion of an ideal gas there will be delta W is equal to delta E. Okay, so now let's come to the next question. The seventh question. Here also they have asked again another sum they have given. So and now let us solve the sum that they have given. So come on, let us solve the sum that they have given. First let us know what is the sum they have given. The question let us learn. The question they have asked is the work done during the expansion of a gas from 4 dm cube to 6 dm cube against a constant external pressure of 3 atom is. So 1 liter of atom is equal to 1.32 joule. So the options they have given is A minus 6 joule will get answer, or B you will get 6 minus 6.8 joule, or C you will get 304 joule, or D you will get minus 304 joule. So let us solve this sum. Now let us solve. So the question, so for work done during expansion of a gas, they asked is work done during expansion of gas. So there is formula for that, that is W is equal to P delta V is the formula for work done for expansion of gas. So work done for expansion of gas, formula is W is equal to minus P delta V. So therefore W is equal to minus V delta final minus V W is equal to minus V bracket V initial minus V final minus V initial is the formula, right? So therefore W is equal to minus 3 is the P, the pressure they have given from here. See the atom constant external pressure P. So V final pressure they have asked is final pressure. So final pressure more, that is 6 dm cube minus 4 dm cube, because 4 is the initial pressure they have given. So therefore 6 minus 4 is the 2, so 6 liter. So 6 liter minus atom into 6 into 101.32 you have to do, because here 3 atom, so 101.32 you have to take. They have asked means here see 1 L is equal to 101.32 joules, so you have to convert it into joule. So for converting that you have to take 101.32 joule. Okay, so by taking 101.32 joule, the 1 liter of atom, or it will be converted into joule. Okay, so for that you have to take this 101.32 joule. So we have got 6 liter of my atom. So therefore minus, so you have to keep that minus, you have to not forget it, because here they have also given they have not given plus, but here you may get confused at last if you not keep minus. So therefore you have to keep the minus. So therefore minus 6 into 101.32 joule is equal to, you will get is minus 608 joule. So therefore 1 dm cube is equal to 1 liter. So therefore the answer is yes. So the answer that you get is minus, sorry, 1 minute, wait. So therefore option B is the answer, that is minus 608 joule you will get. Okay, so you have to keep in each and every formula in any of the chapters that you learn in your 11th, whether it may be some topics will be you'll know the continuation will be there from 11th what you have learned, little bit continuation, little bit more there will be in 12th. The same topics will be there, but little bit extended they may be done. So therefore you will be knowing the formula, but you have to remember every chapter formula, whether it will be 11th or also 12th. Okay, so for solving this like type of sums, means they will give more sums like this only, less they will give like so that small questions they will give it little bit less concentration. So remember formulas so that you may solve the sums like this. See, this also the formula there that they have given in the thermodynamics. While reading that chapter you will know, and while explaining your teacher also you may have know their formula. So therefore it is important. So it is very much important also. These types of sums and the sum last I have given and done the fifth, for the fifth question that I have done, the fifth question I think so. So that is also very much important. Like that sum, that type of sum may also come to your final exam. Okay, so these two sums are very much important. Okay, now after question number 7, let us come to question number 8. See, again another type of sum here also. See, there is more sums in your, whether you see any of the question, whether it may be any of the questions, there means any of the question papers, you will see little bit more sums they may be asked, 50 to 60%. They will ask sums like questions like problems, and leaving that the other questions will be like other explanations, definitions. On that basis, on that they will ask some questions. Now let us come to question number 8. They have asked here is, what will be the work done when 1 mole of gas expands isothermally from 15 liter to 50 liter? So what will be the work done? So what will be the work done that you get when your 1 mole of gas, is expands isothermally. When this 1 mole of gas, it expands isothermally from 15 liter to 50 liter against a constant pressure. Is 1 atom at 25 degrees Celsius. Okay, so first understand the question correctly, then try go to solve the problem. Understand the given, what they have given, so that you will know which formula I have to put, you will get. So understanding the question and seeing the what all the given things they have given, means things they have given in that question, you have to keep in your mind. Okay, so now let us come to option also. So the option A they have given is minus 3542 calories, and option B minus 843.3 calories, and minus C is minus 118 cal, and D is minus 60.23 cal. So these are the things they are given. Now, so directly let us come. I will say you what will be, and I will come to the answer. I will not, because these are some. So as you know, work done in isothermic expansion, they have given a formula that is delta is equal to minus N or T. in which V2 in V2 by V1. So therefore it will be equal to minus 2.303 N0T log V2 by V1 is the formula we will get in the in this so in this thermodynamics chapter you have learned this formula, I think so. Minus 2.303 N0T log V2 by V1 you have learned. Okay, this formula you have learned in this thermodynamics. So see, now after getting this formula, now you have to see the question. Means now you have to see the given things. What are the things that they have given is you have to see. And now N is equal to number of moles is equal to N is the number of moles, that is 1 mole. R is gas constant, that is 2 cal. T is the constant temperature. So these all the what is N, what is R, what is T, these all things you should remember first after seeing the formula. This all should come to mind so that you will get the things correctly. Okay, you will arrange the sums correctly, problem correctly. Next, constant temperature associated with the process is means temperature. For getting temperature they have given is 25 degrees Celsius is the temperature they have given. So therefore 25 plus 273 will be 298 Kelvin. So therefore TC temperature is equal to 298 Kelvin. Where V1 is equal to initial volume. So they have given two volumes here. The first volume is 15 liter and second volume is 50 liters. So they have given here two volume. The first volume is V1 is initial volume and V2 is the final volume. So now you have to put the formula, that is del W is work done is equal to minus 2.303, that they have given in the formula, minus 2.303 into N is equal to 1 mole we have got. So N 2.3 minus 2.303 into 1 into R is gas constant, that is 2. So into 2 into temperature T, temperature that is 298 Kelvin. So therefore into 298 into log, the question there was log 50 by 15. So therefore W is equal to, when you multiply all this you will get is equal to minus 1372.588 into, when you do 15 by 50 by 15, when you solve you will get log 10 minus log 3 will get. So therefore log 10 minus log 3 you will get the answer. If you solve this, log 10 minus log 3 you will get 0.523 will get. So 1372.588 into 0.523 is equal to 7.86 cal will get. Okay, so 7.700 minus 717.83 7.86 cal will get, that is 718 cal. Also you can take, as here they have given only 718 cal, they have not given more. So therefore minus 718 cal is the answer you will get. So if you here solve, if you solve here minus 1372.588 into 0.523 you will get this only, minus 717.86 calories you will get. So therefore the answer for question number 8 is minus 718 cal is the answer. Okay, so therefore this is option C is the answer. Now so okay, so this is the answer. Now let us come to our next question, question number 9. See it, they asked easy question here for you. Okay, so they have asked very small question, 9th question. What it is, come on, let us see. So a process is called reversible. So a process is called reversible only when, only it is called reversible when it is when it is the option they have given is surrounding and system change or same, or there is no boundaries between system and surrounding, or surrounding is always in equilibrium with system, or system is system changes into surrounding spontaneously. So now you have to remember what is reversible. In thermodynamics you learn reversible, so what it is, what is explanation for it, definition for it, you have to remember immediately when you hear this, see this question. Okay, so a reversible process is a process which can be turned into either direction by inducing infinitesimal changes in the system through its surrounding. So therefore thermodynamics, a process is called reversible. A process is called reversible only when the surrounding are always in equilibrium with the system. So reversible, we say in thermodynamics a process is called reversible. The process is said to be reversible only when the surroundings are always in equilibrium. Only when surrounding is equilibrium with the system. So therefore the option is option C. Option C is the answer. Means a reversible means surrounding is always equilibrium with the system. We say in the way when we say when the reversible comes in the thermodynamics. The process of reversible comes in thermodynamics. So therefore here they have given is option C is the answer for this question number 9. Okay, this was your next question. So this I'm telling the answer. So now so here you can see the definition for a process is called reversible when the surrounding are always in equilibrium system. So therefore the answer is C. I have got. So there will be some question easy, some questions that may be difficult. So think correctly. Keep more. You have to know more. Is you should be knowing formula number 1 for solving the questions, means or solving the sum, means for formula you should be very much know about formula so that you may solve the problems that they have given. Next you should be knowing definitions in that chapter so that you may get the answer for the questions that they have asked on the base of the definition on that if they ask. So these are the first two things you should be importantly knowing. For solving any chapter you should be knowing this. Means for solving any questions on the any chapter basis, these things you should be very much well known. Okay, now so let us come to next question. So next is question number 10. So question number 10 they have asked is, here they have asked a sum. So here they have given a sum. Again they have asked a problem. So 2 liters of an ideal gas at a pressure of 10 atoms expands isothermally into a vacuum until its total volume is 10 liter. How much it is absorbed and how much work done is in the expansion. So in this question they are asking 2 liter of ideal gas. In this question they are asking 2 liter of an ideal gas at a pressure is given is 10 atoms when it expands in the into a vacuum, isothermal into a vacuum. So the total volume it becomes is 10 liter. 2 liter it was, now it becomes 10 liter. So for getting that, how much heat it is has been absorbed by that object and how much work is done in this in the expansion. So the questions means the answer is option A it may be 10 joule, option B 8 joule, option C 18 joule of heat may be absorbed, or option D 0 joule of heat is absorbed. So in the isothermal process where is delta is equal to the change in the internal energy and enthalpy change, so therefore it becomes 0. So for the isothermochloric process, work done becomes 0. So therefore there is a vacuum in the when you keep the thing thermally in vacuum, the object does not in the vacuum, it does not implies any external pressure, so therefore the system pressure, it will be 0. So therefore the answer is 0 joule is the answer. 0 joule of heat is absorbed, or 0 joule of work is done in this expansion is the answer you will get. Okay, so therefore answer is 0 joule. Okay, 0 joule is the answer for the question number 10. So keep thinking on the problem, so you should be very much thinking on the problem. You should be knowing the formula. So here also say a small formula means say they have, I see here they have not used formula, they have used the explanation for isochoric process. What is the explanation? By seeing the explanation of isochoric process, they have solved this problem, because in that when isochoric process, work done will be 0, so therefore it will be 0 only, no total answer, it will be 0. So therefore the answer is 0 joule. You will get, they have easily understand, you will be easily understand by seeing the explanation of isochoric process. After question number 10, if we come to the next question, that is question number 11. They have asked here is what will be the standard internal energy change for the reaction in at 298 Kelvin. At 298 Kelvin, what will be the standard internal energy change for the reaction that they have given is OF2, that is in gas, plus H2O, gas gives O2 plus 2HF. So therefore delta H naught is equal to minus 310 kilojoule. So therefore the options they have given is minus 312.5 kilojoule will be the answer you will get, or minus 125.03 kilojoule you will get the answer, or you will get minus 310 kilojoule is the answer you will get, or minus 156 kilojoule is the answer you will get. So now let us solve the problem and let us see what will be the answer you will get in this sum or in this equation. So again same formula you have to use as they have given here, again an equation, and they have given here temperature, so therefore same formula. So delta H is equal to delta U plus delta Ng or T. So here delta Ng is equal to here they have given in this equation, if you see that is 1 plus 2 minus 1 minus 1, that will be equal to 1 is the delta Ng. And so therefore delta U is equal to, if you change the formula, delta U is equal to H minus delta Ng or T. Delta U is equal to minus 310 into 10 to the power 3 is the H. It's H, you will easily know. So minus 1 is the Ng into 8.314 is the, or if you find here, you know how to find the R. In the previous sum I have explained you, so you will be knowing how to find the R. So therefore you may understand how to find the R. In the previous sum, on this sum I have explained T. So T is, they have given temperature already 298 Kelvin, so you have to put that only. So therefore minus 307 minus 307522.4 joule will be the answer. So it is similar to 37 means 310, it will be similar, it will be near to 310. So therefore you have to take, so here option they have given 312, so here they have given 312.5 0.5 and 310 kilojoule. In this, so it is not near to 312 point kilojoule, so that you may take 312. So it is near to 310. Okay, so therefore you have to make approximately, take it, and you have to make approximately it answer as minus 310 kilojoule. So when you make, so therefore correct answer is option C is the correct answer that you will get in this question. So therefore option C is the correct answer. Okay, so this is the how you are using the formula delta H is equal to delta U plus NGRT formula you are using, and you are solving the problem. Okay, so after question number 11, again they are given another sum. So let us solve another sum. So next is question number 12. Again they have given another problem for you in this question. That is, the value for delta U for the reversible isothermal evaporation of 90 gram water at 100 degrees Celsius will be what will be the value of delta U for reversible isothermal evaporation if it has 90 gram of water at 100 degrees Celsius. If it is, they have asked. So the options they are given is 4800 kilojoule, 88.494 kilojoule, 40.8 kilojoule, or D they have asked is 125.03 kilojoule. So now let us solve the problem first. So delta H for 18 gram of water is equal to 40.8 kilojoule is the delta H that you get for 18 gram of water. So for 90 gram of water, if you get, so 40.8 into 18, 14.8 by 18 into 90, if you do, you will get the how much of the kilojoule will we get for 90 gram of water. So therefore it is 204 kilojoule. So therefore 90 gram of water is equal to 90 by 18 is equal to 5 we will get. So therefore N is equal to 5. So therefore delta U is equal to delta Ng or D. So delta Ng is 5 minus 0. So 5 here they have given. 5 minus 0 you have to take. So therefore, because 5 it is that. So therefore 5 minus 0 is equal to 5 will take, because here you have got 5, 90 gram of water, N you have got 5. So therefore 5 minus 0 is equal to 5. So therefore delta Ng is also 5. So therefore delta is equal to delta U is equal to U plus delta Ng or D. So delta Ng is 5. Okay, or is here if you take or is equal to 204 and 5. Okay, so therefore if you take 5 by 25 and if you minus, so if you take it and if you minus, you will get 188.9494 kilojoule. So therefore the answer is 188.494 kilojoule is the answer. So therefore the option in this they have given is 188.494 kilojoule is the answer we have got. So therefore in the option B they have given this answer. So therefore option B is our answer for question number 12. Okay friends, so therefore I will, so this is therefore on option B, 188.494 kilojoule is the answer for your next question, means your to question number 12. So you have to remember this formula. So these formulas, as I said, formula is important, so remember these formulas, then only you will understand easily. So Now let us come to okay, after this, now if we come to question number 13, they have given is which of the following relationship is not correct for the relationship between delta H and delta U. So for relationship between delta H and delta U, which of the following relationship is not correct, they are asking in this. So here they have given 4 options, that is when delta N is equal to 0, then delta H is equal to delta U, and 4 options. So now let us see. So therefore delta H is greater than delta U, means smaller than delta U. So the relationship between delta H and delta U is they have given is delta H is equal to delta U plus delta PV. So therefore delta H is equal to delta U plus delta Ng or T is the thing you have to take, this option you have to take. So where delta Ng is equal to 0, okay, delta Ng, if you for delta Ng is equal to 0, if you take, you will get delta H is equal to delta U. If you take delta Ng is greater than 0, so you will get smaller than 0, you will get delta H is equal to delta U plus delta Ng or T. And if you get delta Ng is greater than 0, you will get delta H is equal to delta U minus delta Ng or T. So therefore for delta Ng or T is equal to 0, delta H is equal to delta U is the option you will get. So therefore here they have given option is when delta Ng or T. So when delta Ng or T is equal to 0, if it is equal to 0, delta H is greater than, means delta H is smaller than delta U. So therefore the answer is option D is the answer for question number 13. Okay, so therefore option D is the correct answer for question number 13. Now come on, let us go to our next question. That is question number 14. So next is question number 14. Here they have asked if the heat change at constant volume. Another problem they have asked. So the another problem they have asked is if the heat change at constant volume for decomposition of silver oxide is 80.25 kilojoule, what will be the heat change at constant pressure? So here they have asked, the question they have asked is, see, now the heat change in the constant volume, for constant volume the heat change, that is for element silver oxide, it is 80.25 kilojoule is the heat change for the volume for the heat change at constant volume for decomposition of silver oxide. So now they are asking what will be the constant pressure. So they have given constant volume for silver oxide, but they are now asking what is the constant volume if we get when is the heat change, when there is heat change. So now let us solve the problem. So heat change at constant volume for decomposition of silver oxide they have given is 80.25 kilojoule. So Ag2O silver oxide formula is, so it is solid, and that by doing the solving you will get the equation 2Ag solid plus 1/202 gas you will get. Okay, by this equation, from this equation delta Ng is smaller than 0, so delta H is equal to delta E plus delta Ng or T, the first law of thermodynamics, this you have to use. So therefore delta ng is smaller than 0, so therefore delta h is smaller than delta h, so therefore delta h e is smaller than 80.25 kilojoule. So therefore, okay, so this is the answer. 80.0 into C25 kilojoule is the answer for your question number 14. Okay, so this is the answer, and the question also you have understand, I think so. So see, the basic formula in this thermodynamics till now you have mostly means the basic formula that you have used more till now is delta H is equal to delta E plus Ng RT is the formula that you have used till now. In most sum you have used, you can see, no? So keep this equation, this formula in your mind in this thermodynamics question. Now after question number 14, if we come to our next question, that is question number 15. Here they have asked again a problem they have asked for you. So come on, let us solve this problem. Another problem let us solve. So the problem that they have asked here is a molar heat capacity of water at constant pressure. So the molar heat capacity of water at constant pressure Cp is, at constant pressure Cp is 75 joule kilo per mole. 75 joule kilo per mole is the molar heat capacity of water in its constant pressure. If it is 10 kilojoule of heat is supplied to 1 kg water, 1 kilo water, which is free to expand, that water that is free to expand, the increase in temperature of water is how much of temperature will be increased in the water. So the temperature, as now it is given in the Kelvin, so we have to take it as Kelvin. So therefore 2.4 Kelvin is the 2.4 Kelvin is option 1. Option 2 is 4.8 Kelvin they have given. Option C they have given is 3.2 Kelvin. Option D they have given is 10 Kelvin. 10 Kelvin they have given as the these are the 4 options they have given. Now again let us come to solving the problem by using the formulas. So as they have given the relationship between the heat supplied, molar heat capacity at constant volume, and the temperature changes, that formula is Q is equal to M into Cp delta T, where Q is equal to 1 kilojoule they have given. So 1 kilojoule is equal to 1000 joule is the answer, where number of moles is equal to M is equal to mass by molar weight, is that is equal to 100 by 18. 100 by 18. So therefore by substituting the values in this given expression, that given formula, 1000 is equal to 100 by 18. 18 here they are given, 100 we have taken by formula, mass molecular weight by seeing this in these questions they are given. So now, so therefore 75 is the thing Cp they have given. So and delta T, that we are going to find, that is temperature we are going to find. So therefore so hence the temperature change is 2.4 kilojoule is the temperature change when you solve this problem. So therefore delta T is equal to 2.4, sorry, kilojoule, not Kelvin. So therefore the answer is option A is the answer. Okay, so option A is the answer for question number 15. Now let us come to next question, that is question number 16. So again another problem you can see here. They have given another problem, another sum they have given, that is here they have asked what is the work done when 1 mole of gas expands isothermally from 25 liter to 250 liter. Here they have increased. There in the same question they have given, there they asked 15 to 50 liter. 15 to 50 liter. Here they have given 25 to 250 liter they have asked. Okay, at a constant pressure of 1 atom, they have asked, and a temperature of 300 Kelvin. So a temperature that they have asked is 300 Kelvin is the temperature they have given. So therefore the options they have given is whether it may be, the answer we may get is minus the work done is minus 3452 joules, or it may be minus 5744 joules is the answer we may get, or minus 2657 joule is the answer we may get, or minus 4890 joule is the answer that we may get. They have asked here. So let us come to the answer of this question. If we see the answer of this question, so the work done for an isothermic process, the formula is the work done is equal to n minus n or t and v2 by v1 is equal to minus 1x. So n or t e means in this n or t, n or is equal to we have to take 8.314 is the n or they have given in the while sharing that sum. You can see 8.314 you have to take in this sum note. In this reading that questions, they may means while reading this topic in thermodynamics chapter, there you will learn what is the formula, what you should take. N is constant that you have to take into 300. So 300 is the current temperature 300 they have given in the question. So V2 is the final temperature. So final temperature in the formula in the back sum, V2 is the final temperature. Final temperature by initial temperature you have to take in the like that you have learnt in the formula. The where we done that is maybe 6 is 8th question I think. So there you have learnt. Similarly, they have given 15 liter. Here they have 15 to 50 liter they have given question. Here they have asked to from 25 liter to 250 liter. Okay, so therefore 250 by 25, so therefore it will be 10. So therefore 8.314 into 300 into 10, it will be minus 5744 joule is the answer you will get for, that is for the work done. So therefore the work done for this in this question the asked is minus for in this sum is in this problem is minus 5744 joule. Okay, so therefore the option is, as in this three option, the correct answer is option B. Okay, option B is the correct answer for in this three questions. In these three questions, what they are in these four options, sorry, the correct answer is option B, that is minus 544 joule. Sorry, minus 5744 joule. Okay, so this is the answer for question number 16. Now again if we come to question number 7, here they have asked an expression they have asked. Okay, so here they have asked a expression. So for an isothermal reversible expansion process, the value of Q can be calculated by the process. So for an isothermal reversible expansion in this process, the value of the Q for Q can be calculated by the expression. By which expression? Using which expression you can calculate the this isothermal reversible expansion. So in the solving the problems there, I give there we have used this expression, that is q is equal to minus 2.303 nRT log v2 by v1 by using so the answer is q is equal to. So next question number 17. So as you see, the answer will be, as I said, q is equal to minus 2.303 nRT log v2 by v1, the formula that we used to solve there the problem. We used to solve the problem we were using this formula. So how that it comes, first we will know. So for an isothermic reversible process, for any isothermic reversible process, whether it may be anyone like delta T is equal to 0, therefore delta U is equal to NCV, delta T is equal to 0 it will be, and also it can be delta U is equal to Q plus W is equal to 0 you can take. So Q is equal to minus W, so for any isothermal reaction W is equal to N or T and V2 log by V1, so therefore it can be written as minus 2.303 N or T log V2 by V1. So therefore Q is equal to minus W is equal to 2.303 N or T log V2 by V1. Okay. Okay, so in like this also you can write. So be careful, they have given here to confuse you. Okay, this here plus and minus they have given, but the real thing it comes is minus only. Okay, don't get confused in these types of sum, as they give these types of term sums for creating confusion in you. So you may get confused and write wrong answer. For that they may give this type of sums. Next is the next question is question number 18. So question number 18 is our next question. So it's another problem. So a system change from state of x to y with the change in its internal energy measuring to 25 kilojoule per mole by a reversible path and returns from y to x by an irreversible path. What will be the net change in the internal energy? So in this problem they are asking a system change from state x to y. From x to y the system changes its state with a change in its internal energy. So with the change in its internal energy it changes. Okay. So the measuring that they have given for this system is 25 kilojoule per mole they have given. In this reversible path, if it returns again and if it goes from, as you know, it is going from x to y. If it returns and goes now from y to x in irreversible path, what will be its net change in internal energy? They are asking. The option that they have given is A, they have given 25 kilojoule, B, greater than 25 kilojoule, C, lesser than 25 kilojoule, 0 than 0 they have given. So the correct answer is 0. Why? Because in any cyclic process, you have learnt in thermodynamics chapter, while reading some of these topics you learned, in any cyclic process, if a net change in internal energy is 0, if the net change is 0, then change in internal energy does not depend on the path by which final stage is reached by the change in internal energy does not depend on the path which the final stage is reached. So therefore inside the cyclic process net change in internal energy will be 0. You learned in thermodynamics. So when you see that, so therefore the answer will be 0. Okay, so therefore the answer for question number 18 is 0. You have to write in your final exam if it comes. Next is, okay, so this was your next question. Therefore, question number 18 is equal to, answer is 0. Now, let us come to next question, that is question number 19 they have given is, what will be the change in internal energy when 12 kilojoule of work is done on the system and 2 kilojoule of heat is given by the system? Understand the question, what problem? Now again another problem they have given. But this problem was very simple because this was containing some explanation that was there in a textbook. By seeing that explanation, you can easily tell the answer. Here, no solving the problem. 0 it will be easily you can say by seeing the cyclic process. Net charge and internal energy will be 0. So next is the question number 19. They have asked here is, what will be the change in internal energy when 12 kg of work is done on the system and 2 kg of the heat is given by the system? So they are asking here, what will be its internal change when you give 12 kg, not kilojoule, 12 kilojoule of work is done on the system and 2 kilojoule of heat is given to that system. So the options is A, they are given A plus 10 kilojoule, B minus 10 kilojoule, C plus 5 kilojoule and D minus 5 kilojoule. So heat evolved means how much heat is evolved is minus 2 kilojoule and work done on the system is plus 12 kilojoule. So therefore delta U is equal to Q plus W, as you know. So therefore minus 2 plus 12 will be equal to plus 10 kilojoule. So therefore in the option, option A is the answer for question number 19. Okay, so therefore 10 kilojoule is the change in internal energy when 12 kilojoule of work is done on the system and 2 kilojoule of heat is given by the system. Okay, so like this you have to solve the sum. This was a little bit easy sum, not twist that much twist, but easy it was. So it was easy, so that's why we solved it very fastly. Now let us come to next question, that is 20th question. So here they have asked a reaction. So here in 20th question, a reaction proceeds through two paths 1 and 2 to convert X, Z. So here there is a given circle, path 1, path 2, X, Z, Y. So they are asking, what is the correct relationship between Q1 and Q2. So here in this circle, Q1 and Q2 are the three things that is rotating from X, Y, Z. So in these three, which one is the correct relationship between them, they are asking. So Q is equal to Q1 into Q2, Q is equal to Q1 plus Q2, Q is equal to Q2 minus Q1, Q is equal to Q1 by Q2, which is thing. So see, so the internal energy, that is we write it, denote it as Q. So it is a state function. The internal energy that which you denote it with the symbol Q, it is a state function. It's a function. So Qxz, so Qxz is equal to Qxy. So Qxz is equal to Qxy plus Qyz is the formula. So here xz for Q is xz, it will come. So xz is Q. Here they have given from x to z, if it goes, that is Q. So therefore Qxz can be denoted as Q here. Q next is Qxy. So here Qxy is Q1. See here in this circle they have given Q1 is equal to from x to y Q1, x to y Q1. Okay, so therefore Qxz to xy can be written as Q1 plus Qyz. So Qyz can be written as Q2 because see here y to z Q2 path 2. So therefore Q2. So therefore Q is equal to Q1 plus Q2 is the formula, is the equation which you get. So therefore the answer is option B, that is Q is equal to Q1 plus Q2 is the answer. Okay, so therefore this is the answer for 20th question. So like this you have to remember. See here in this circle they have given think correctly and answer the question what they have given. Think from the topics what they have given. Okay, don't miss any point. If you miss, then you may get confused. Okay, so therefore, before even solving some, think correctly what will be the answer, what may be answer. Think correctly whether I have written it correctly or not the answer. Then you write the answer. Then you solve the answer. Okay. Next, the next is question number 20. They have given. Here they have asked another problem. So they are asking more problems. As you see, you can see still now till 22 first question they have asked more problems, and little a small left 40% they are till now in this 50 to 60% they have asked problems, and 40% some explanations they have asked. Okay, you can see. So next is a system absorbs 50 kilojoule heat and does 20 kilojoule of work. What is the net charge and the internal energy of the system? So they are asking here a simple thing. See, a system, it absorbs 50 kilojoule heat. So a system absorbs 50 kilojoule of the heat from its surrounding. From its surrounding, it absorbs 50 kilojoule of heat, and then it does the 20 kilojoule of work it does. By using that 50 kilojoule, it uses only just 20 kilojoule. So what is the net change? What is the net change in the internal energy of that system? Internal energy of that system, what will be the net change? Option A they have given, will it increase by 30 degree? Will the net change increase by 30 kilojoule? Will the net change in option B they are giving, will net change decrease by 30 kilojoule? And C they are asking, will the net change in internal energy of the system will increase by 70 kilojoule? Option D, will the net change in the internal energy of the system decrease by 70 kilojoule? These in this option. So now let us solve. So they have given Q is equal to 50 kilojoule. So 50 kilojoule of the heat is absorbed by its surrounding they have given. And W is the work done by the system. So it can be negative also. So therefore, that is minus 20 kilojoule, means minus 20 kilojoule because it has used it. The heat, that 20 kilojoule of heat is used for doing that work. So therefore, it can be written as W is equal to minus 20 kilojoule. Okay. So the formula is delta U is equal to Q plus W is equal to 50 minus 20 kilojoule. So therefore, the internal energy that we get is 30 kilojoule. So it can be increased by 30 kilojoule. So therefore, the correct answer is option A, increase by 30 kilojoule. So therefore, increase by 30 kilojoule is the right answer for this question number 21. Okay, so that's why see, you have to remember this formula from continuously 2 to 3 problems. We are using this formula delta is equal to Q plus W. See here also we wait 1 minute here. See here also we used, and still back also we used. So therefore, you have to remember this formula as you are using it continuously, and many more formulas that are in thermodynamics you have to remember it. So that's why by using that formula only you can solve any sums in your Neet CET if they ask from thermodynamics chapters. Little bit in every chapter there are some questions in Neet CET or JE. So therefore you have to remember this, all the problems, equations what they have given. Okay, so therefore for question number 21, the answer is A, increase by 30 kilojoule. So the net change in the internal energy of a system is the increase by 30 kilojoule is the answer. Okay. So next is question number 22. Question number 22. Work done on an ideal gas of cylinder when when compressed by an external pressure in a single is shown below. So here in the picture they are showing the work done on an ideal gas in a cylinder. The work done on the ideal gas of a cylinder when it is compressed by an external pressure. When that ideal gas is compressed by any other external pressure in that single, it is shown below in this diagram. You can see they have shown the cylinder in that the external pressure in the first diagram. They have shown the external in the ideal gas work done. They have shown an external pressure. Now they are asking the question, which of the following graphs will show the work of the work done on the gas? So in these four options, which will be the work done on the ideal on the gas? Work done on the gas will be, they are asking. So option A, option B, and option C, the graph you can see. So now, let us see what will be the answer. So the pressure is constant and equal to px. So in that figure by which we can see in this diagram, so the where the pressure is constant and it is equal to px. Also this process is, it is done in a single step. This process is done in a single step, and therefore it is a straight line parallel to volume axis. So it is a straight line which is parallel to volume axis, and has a value of px. So it is having a value of px. So therefore work done is equal to px, delta u is equal to area under the p minus v curve. So therefore option A will be the right answer. Option A will be the right answer for the question number 22, we can say. Okay, so like this you have to remember this diagram for seeing the correct answer. Next question, another they have asked here is in 23 question they have asked is the enthalpy change of a reaction does not depend upon. So the enthalpy change in a reaction that does not depends upon, which it does not depend, they are asking where it does not depend upon state of reactants and products, it does not depends upon nature of reactants and products, will it does not depends upon different intermediate reaction, or will it does not depends upon initial and final enthalpy change of reaction. Which one is the right answer they are asking? So therefore enthalpy change it is a state function. So enthalpy change, it is a state function. The explanation for enthalpy change I am giving you, by that only we will get the answer for this question. So therefore the enthalpy change, it is a state function, so it does not depends on the path taken by the reaction. So the enthalpy change, it does not depends on the path that we have taken for that reaction. And the enthalpy change, it only depends on the different difference of final and initial values of the enthalpy change. So it depends upon the final and initial values of the enthalpy change. So therefore different intermediate reactions does not happen here. So therefore different intermediate reactions, it does not happen in this enthalpy change. So therefore the wrong this here, the thing that does not happen in the enthalpy change is different intermediate reaction does not happen here. In this explanation, as you can see, they are not said that intermediate reaction happened. So therefore it is the wrong option, we can say. So therefore 23 answer is different intermediate. So the enthalpy change of reaction does not depends upon the different intermediate reactions. Okay, so this is the answer for question number 23. Now if we come to the next question, that is question number 24. Here in the question number 24 they are asking us a reaction. They have given two reactions here. One is COG plus half O2 gives CO2, that is gas, and the next reaction is Ag2O, that is solid, gives 2Ag solid plus half O2G O2, that is gas. So in that they are asking which of the following statement is true about this. Following statement is true about these two reactions they are asking. Like they are asking for delta H is greater than delta E. For question number 2, equation number 2, delta H is smaller than delta E. Or for question number 1, delta H is greater than delta E, sorry, smaller than delta E, and delta, for question number 2, delta H is greater than delta E. Or for 1 and 2, delta H is smaller than delta E. Or for 1 and 2 equation, delta H is greater than delta E. So which one is the correct, they are asking. And therefore So let us see what is the answer. So as you see in the given equation, they have given two formulas, means two reactions they have given, where first one is CO plus half O2 that gives CO2, next one Ag2O that gives 2 Ag plus half O2. So therefore delta H is equal to delta E plus delta Ng or T is the formula that we commonly use. Till now we have used it. So therefore delta E is change in internal energy of a system, del R is the gas constant, T is the temperature, delta Ng is equal to number of moles minus number of moles in the gaseous product, number of moles in the gaseous reactant. So therefore in the first reaction that they are given, COG plus half O2G gives CO2, in the delta Ng is equal to 1 minus half 2 minus 1 is equal to gives minus 1 by 2, that is greater than 0. So therefore delta H is greater than delta E. In the second equation that they are given, Ag2O gives you 2 Ag plus half O2. Therefore delta Ng is equal to half plus O minus 0 minus 0, that gives you half. So therefore here the 0 is greater than delta Ng, so therefore the option is A. So therefore answer is option A, for which delta H, first reaction is delta H is greater than delta E, and for equation 2 delta H is smaller than delta E is the answer. Okay, so now option A is the answer. Okay, after question number 25, again another question, that is question after 20, question number 24, another question is 25, and here again you can see another reaction they have given, again same reaction they have given here. COG plus half O2 gives CO2 gas. So here, but here they have asked different question. Here they have asked how are delta E and delta H related for the reaction. So how both delta E and delta H is related to this reaction that they have given, CO2 gas reaction they have given. How this both is related to this reaction they have asked here. So options they have given is option A, they have given delta E is equal to delta H is equal to delta E minus 0.5 RT, delta H is equal to delta E minus RT. Next is delta H. Option C they have given is delta H is equal to delta E plus 0.5 RT, delta H is equal to delta E minus 1.5 RT. So therefore the correct answer is we have to solve. So therefore delta H is equal to delta E by delta H is equal to delta E plus delta Ng or T. So therefore we, by solving, if we solve in this, we by using this formula, if we solve delta H, we get delta H is equal to delta E minus 0.5 RT is the answer we get, and 0.5 RT, the option they have given is option A is the in option A they have given 0.5 RT. So therefore the correct answer is option A is the correct answer for question number 25. So like this we have to think. Now next they have given question number 26. In question number 26 they have given two columns and we have to match both the columns correctly. In the column 1 they have given reactions, in column 2 they have asked delta H is equal to delta U plus 2 or any other options, whether it may be they have asked. Column 1, let us read the reactions first. H2 that is in gas plus P or 2 that is also in gas gives you 2HP or that is in form of gas. The next reaction that they have given is PCl5 that is in the form of gas, and that gives you PCl3 that is in the form of gas plus Cl2 that is also in the form of gas. Next N2 that is in the form of gas plus 3H2 that is also in the form of gas, that gives you 2NH3 that is in form of gas. Final question they have given is 2N205 that is 2N2O5 that is in the form of gas plus gives you 4NO2 that is in the form of gas plus half water that is in the form of gas. So now for seeing the answers in column 1 they have asked, so therefore For first one, that is H2G plus P or 2G gives you 2HP or G, that they have given. Question number 1 means column 1 first A question. For that we have to solve. If we solve, we get delta Ng is equal to 2 minus 1 minus 1 we have to do by using that formula. 2 minus 1 minus 1, if we do, we will get 0. So therefore delta H is equal to delta U, because delta Ng is 0 means we will remove it. So therefore delta H is equal to delta U is the for answer for question A. So it comes under in option 3. You can see that answer. So therefore here you can, so option 3. Okay, sorry, 1 minute. This is one. Also question number. So okay, so option A is delta for delta H is equal to delta U is the answer for question number A. Now if you come to next question number B, they asked is PCl5G, that gives you PCl3 gas plus Cl2 gas. Delta Ng is 2 minus 1 is equal to 1. So therefore delta H is equal to delta U plus RT will be the answer which will come. So therefore in this the option, let us see where it is, this option you can see. So so therefore in option 4 you can see, in column 2 option 4 you can see this answer. So therefore okay, so option 4 is the answer for question number 2. Now if we come to question number C, they asked in the first column N2 gas plus 3H2 gas gives you 2NH3 gas. So therefore delta Ng is equal to 2 minus 3 minus 1, that will give you minus 2. So therefore delta H is equal to delta U minus 2. What is the answer that you get? So therefore see, N2 gas plus 3H2 gas gives you 2NH3 gas. So therefore option 1 is the answer for question number 3 in the column 2. Option 1 is the answer. So therefore question number, so okay. Now if we see the last question, that is 2N2O5, that is gas gives you 4NO2 gas plus O2 gas. Delta Ng is equal to 4 plus 1 minus 2 is equal to 3. So therefore delta H is equal to delta U plus 3. What is the option we'll get, because 3 is here given and Ng we can write as RT. So therefore option final is left over is option means 2 they are left over in column 2. So therefore it is the answer. 1 minute. So this is how so option, so H2 gas plus VO2 gas gives you 2 HPR gas. For that answer is delta H is equal to delta U. And next question is B, PCl5 gas gives you PCl3 gas plus Cl2 gas. For that answer is delta H is equal to delta U plus RT. Next question number C is N2 gas plus 3H2 gas gives you 2NH3 gas. For that answer is delta H is equal to delta U minus 2 RT. Finally question number D, answer is 2NR into O5 gas plus gives you 4NO2 gas plus O2 gas. For that answer is question number means column 2 4. So next question is question number 27. So here again they have asked another sum. So here they have asked to consider the given diagram for 1 mole of gas X and answer some of the following. The process is to be represents. So here if you see the diagram, in this they have asked, by seeing this diagram they have asked to solve the question. They have given the diagram for 1 mole of gas X and we have to answer some of the following questions. So option given is here, isobaric change is there in this diagram, or it is isothermal change, or it is adiabatic change, or it is isochoric change they are asking in this. question. So question number 27. If we see a process from A to B has a constant volume that is equal to 10 liter is the constant volume of that process from A to B. So therefore for A to B is delta V is equal to 0. So therefore isothermic process the volume remains constant. So therefore delta V is equal to 0. So therefore the process A to B is an isochoric process. So therefore the correct answer is isochoric process that has constant pressure, means that has constant volume. So therefore option D is answer for question number 27. So once again you have see this option. So let us come to the next question, that is question number 28. Next question is question number 28. So let us come to question number 28. So as you know, according to the first law of thermodynamics, that is delta U is equal to Q plus W. So in some special cases the statement can be expressed in some other way also, and they are asking which of the following is not a correct expression to explain that statement. In the options they have given option A at constant temperature Q is equal to minus W. Option B, when no work is done delta U is equal to Q. Option C, in gaseous system when delta U is equal to Q plus P delta V. Option D, when work is done by the system delta U is equal to Q plus W. So let us see each option. So at constant temperature delta T is equal to 0. So therefore delta U is equal to NC4 delta NCV delta T. So delta U is equal to Q plus W is equal to 0. So therefore Q is equal to minus W you can write. So it is also a little bit form of the delta U is equal to Q plus W for equation. Next, when work done is 0, W is equal to 0. So therefore delta U is equal to Q plus W. So therefore delta U is equal to Q is also the another option is okay. So in gaseous system W is equal to P delta V. So delta U is equal to Q plus W. So delta U is equal to Q plus P delta V we can get. Next, when work is done in the last option by the system W is negative, so therefore delta U is equal to Q minus W. So it is not a right option, we cannot get negative. So therefore when the work is done by the system delta U is equal to Q plus W, is this option D is the answer for question number 28, which is not a correct expression. So therefore the correct answer is option D. When work is done by the system delta U is equal to Q plus W is a wrong expression. You can say that the formula is also same and this is also same, why it is wrong. But see here, if we take it as negative, work done is negative, then it will become delta U is equal to Q minus W. So therefore we will not get any negative sign in this thermodynamics first equation. So therefore this equation may get wrong. So that's why option D is the wrong answer for our equation, means our question. So after question number 28, answer, that is answer D. Now let us come to our next question, that is our Next question number 29. So let us come to our next question, that is question number 29. So question number 29, it's an so let us come to the next question, that is question number 29. So here we have another problem, as I said. So let us come to the question. So 200 joule of heat was supplied to a system. So we have supplied 200 joule of heat to a system at a constant volume. At a constant volume, we have supplied the heat. It resulted in the increase in temperature of the system. So it resulted in the increase of the temperature of that system. That is from 298 to 323 Kelvin. The temperature has increased in that system. So what is the change in the internal energy of the system? They have asked the question. And if you see the question, they have given that 200 joule of heat was supplied in the system at a constant temperature, constant volume, and it also resulted in the increase of that temperature from 298 to 323 Kelvin. So we have to find the internal energy of that system. Let us come to the option they have given. Is option A, they have given 400 joules is the internal energy of the system, or 200 joules is the internal energy of the system, or 50 joule is the internal energy of that system, or 150 joule is the internal energy of that system. So if we come to the question, they have said that at a constant volume. So therefore in a constant volume, delta V will become 0. As you know till now, with the problems that we have done, there is taken as the constant volume, delta V is equal to 0, it will come. So W is equal to minus P, delta V is equal to 0. So therefore WU is equal to Q is equal to 200 joule. So therefore in the question that they have given, so therefore as you know, delta V will be 0, so therefore it will be delta U is equal to Q is equal to 200 joules. So therefore the internal energy, the change in the internal energy in that system will be 200 joule will be the answer we will get for question number 29. Answer B, that is 200 joule. Okay, so therefore the answer is 200 joule for question number 29. So now our next question is question number 30. So question number 30, it is also a problem and they have given a reaction also. So let us read what they have given. Reaction of methanol with dioxygen was carried out. So a reaction has been carried out by methanol with its dioxygen was carried out, and delta U was found to be, we got delta U as minus 726 kilojoule per mole, and temperature at 298 Kelvin we got. And the enthalpy change of that reaction will be, the reaction we got is CH3OH liquid form, it is plus 3 by 2 O3 that is in the gaseous form, O2 that is in the gaseous form, gives CO2 that is also in the gaseous form. Next equation is, next for reaction is 2H2O that is in liquid form. Delta H is equal to minus 726 kilojoule per mole. Okay, so this is the two reactions that they have given, and they are asking us to find, by using this reaction, find the answer. Option they have given is option A is equal to, and we will get minus 741.5 kilojoule per mole, or option B minus 721 kilojoule per mole, or option C plus 741.5 kilojoule per mole, or option D plus 721 kilojoule per mole. We will get the answer. Let us see. So enthalpy change for reaction delta H is given. We have used only one expression for delta H till now, that is delta H is equal to delta U plus delta Ng or T, where delta H is change in internal energy, delta Ng is change in the number of moles in this reaction. So therefore delta Ng we can take as change in an Ng product minus reactants. So therefore it will be equal to 1 minus 3 by 2 is the answer. So therefore delta Ng will be equal to 0.5 moles and delta U will be equal to minus 726 joule that they have given in the sum kilojoule. So therefore temperature will be equal to plus 298 kilojoule and R will be equal to 8.314 into 10 to the power minus 3 kilojoule per mole. So by substituting this only formula, delta H is equal to minus 726 plus minus 0.5 into 298 into 8.314 into 10 to the power minus 3. So therefore the answer is delta H is equal to minus 727 kilojoule per mole. So therefore the answer for question number 30 is option B, minus 727 kilojoule per mole. So this is the answer for question number 30. Let us come to next question, that is question number 31. Here they have asked again in small explanation from definition. They have asked, His law is applicable for the determination of heat of which of the following, whether it is a transition, formation, reaction, or all of these. So next question is question number 31, as I said. So let us see what will be the answer. So as you know, His law of constant heat summation means the standard enthalpy of this reaction, which takes place in several steps. Its standard reaction takes place in several steps, and it is the sum of the standard enthalpies of intermediate reaction into which overall reaction may be divided at the same temperature. We will divide the overall reaction. So therefore delta H is equal to delta H1 plus delta H2 plus delta H3. So it is applicable for determining the heat of formation, transition, reaction, hydration and many other things. So therefore by seeing this, what is the answer, you can only guess now. So therefore answer is option D. So therefore 1 minute. So therefore answer is option D for question number 31. Now let us come to question number 32. Here they have asked a little bit of reaction question. So if enthalpy of an overall reaction, if enthalpy of that overall reaction that they have given x tilde y along one route is delta or h. So equation is delta or h, and delta or h1 and delta or h2 and delta or h3 etc. are representing their enthalpies of reaction that is leading to some product. They are getting some product by this reaction, that is y. Then what is delta H is? Will it be delta H is equal to delta RH1 plus delta RH2 plus delta RH3 and keep on going? Or will it delta RH is equal to delta RH1x plus into delta RH x into delta RH3 and keep on going? Or will it be delta RH is equal to delta RH1 plus delta RH2 minus or delta RH3 like that? Or option D, that is they have asked is delta RH is equal to delta RH1 into delta RH2 in x into. So let us see the answer for question number 32. So see, according to Hess law, now we will learn. So delta H is equal to delta RH plus RH1 plus delta RH2 plus delta RH3, where H1, H2, H3, etc. are enthalpy of the steps. So therefore option A is the right answer for question number 32. You can see according to Hess law, the correct answer is option A for question number 32. 1 minute, let us come to okay, option A is the right answer for question number 32. Now next, let us come to next question, that is question number 32. So here they are asking, they have given a diagram which thermochemical process is shown by in the following diagram. So they have asked from X to P, P to Q, Q to Y, and from X to Y. They have written delta or H1, delta or H. So standard in the options they have asked, is it a standard enthalpy of reaction is happening. So next is they have asked option B, Born-Haber cycle of lactic enthalpy. Option C, Hess law of constant heat submission, or option D, standard enthalpy of a solution. Let us see which is the correct answer. So in the thermodynamic process shown in that figure, Hess law of constant heat is happening. As you know, in first X belongs to delta Hy. So therefore in the X till Y is delta H. In diagram that they have given, X to P is delta H1, P to Q is delta H2, and Q to Y is delta H3. So therefore it will be the equation of Hess law, that is delta H is equal to delta H1 plus delta H2 plus delta H3. The equation of Hess law we are getting. So therefore the right answer is option C. Option C, Hess law of constant heat submission. Okay, option C is the right answer for question number 33. So before answering any question, see the question carefully and then try to answer that question. Don't be in any hurry to answer that question. Okay, now if we come to our next question, that is 34, here also they have asked another question, that is which of the following does not represent enthalpy change during phase transformation. So during phase transformation, which of the following options they have given that does not represent the enthalpy change? Standard enthalpy of fusion, or standard enthalpy of vaporization, standard enthalpy of sublimation, standard enthalpy of formation. Let us see which one is the right answer. So standard enthalpy of formation, it does not represent enthalpy change during phase transformation. There does not happen any phase transformation, phase change in formation. So a new product is formed during the reaction in this standard enthalpy of formation. So therefore the the right option for this question is that which of the following does not represent enthalpy change during phase transformation. The right answer is option D, standard enthalpy of formation. So let us come to next question, that is question number 35. So here they have asked which of the following reaction will have the value of enthalpy of neutralization, means 57.1 kilojoule per mole. So therefore the answer is option C. The Hess law is answer for our question number 33. So after question number 33, let us come to next question, that is question number 34. So which of the following does not represent enthalpy of change during phase transformation? So therefore standard enthalpy of fusion, standard enthalpy of vaporization, standard enthalpy of submission, standard enthalpy of formation. So they are asking which does not represent the enthalpy of change during the transformation. So therefore the standard enthalpy of formation in last I said. Next, now question number 35, that is they have asked here, they have asked a big question, means they have asked here for which of the following the reactions here they have given. Four options in that reaction they have given. in this reaction, which of the following, which one will have the value of enthalpy of neutralization, that is 57.1 kilojoule per mole is the enthalpy of neutralization, value of enthalpy of neutralization. So for option 1 they have given CH3COOH plus NaOH gives us CH3COONA plus H2O. Option B, HCl plus NaOH gives NaCl plus H2O. Option C, HCl plus NH4OH gives us NH4Cl plus H2O. Option D, HCOO4 plus NaOH gives us HCOONA plus H2O. So in these options we have to find which one is the correct. In this means in these reactions we have to find which one is the correct reaction, for which we will get the enthalpy of value of enthalpy of neutralization 57.14 kilojoule per mole we will get. We have to find. So enthalpy of the neutralization that they have given is 57.1 kilojoule per mole. So for a strong acid and for a strong base, since HCl is a strong acid and NaOH is a strong base, so neutralization reaction of HCl plus NaOH gives NaCl plus H2O as enthalpy as neutralization as 57.1 kilojoule per mole. So therefore the correct option is the option B, HCl plus NaOH, that gives NaCl plus H2O is the correct, and is the correct answer, means it is the reaction which gives the value of enthalpy of neutralization, that is 57.1 kilojoule per mole. Okay, option. So let us take it as option B. So therefore option B is the correct answer for question number 35. After completing question number 35, if we come to question number 36, here they have asked what will be the enthalpy change of conversion of graphite into diamond. So what will be, will get the enthalpy change when we convert the enthalpy change of conversion of, when we convert the graphite into diamond, what is the enthalpy change we will get? And the information that they have given is, see, graphite delta comp H is equal to 391.25 kilojoule. C diamond delta comp H is equal to minus 393.12 kilojoule. So both are minus they are given. So this is also like a sum. We have to find C. So graphite to diamond. So delta H is equal to delta CH plus delta CH product, reactants and products. So therefore graphite is the reactants and and diamond comes under the product. So therefore 391.25 plus 393.12 kilojoule in the questions here, in the graphite delta H value they are given and diamond delta H value. So therefore that is minus 391.25, minus is there, so minus into minus 3 minus 393.12, so minus into minus plus it will become. So therefore minus 391.25 plus 393.25 kilojoule. So if we do the calculation, we will get that is equal to 1.87 kilojoule. So therefore the answer is option D, that is minus 1.87 kilojoule per mole is the answer we will get. That is the value of the enthalpy change when we convert the graphite into diamond. Okay, so let us take option D is the correct answer. So option D is the correct answer for question number 36. So after option 36, sorry, question number 36. So after question number 36, answer that is 1.8 minus 1.87 kilojoule, option D. Now let us come to question number 37. So here they have asked which of the following expression is correct to calculate the enthalpy of a reaction. So they have asked that in the following four options that they have given, in this which of the following expression, the expressions they have given in that option, that in these expressions that is correct for us to calculate the enthalpy of the reaction. Enthalpy of a reaction, to calculate enthalpy of reaction, which of the following four option, in this four option, which one is the correct one, they are asking in the question number 37. So see, so enthalpy change of reaction. So first one they have given is 1 is to delta H reaction is equal to delta B E reactants minus delta E B into E products. Okay. Next, delta H reaction is equal to delta H products minus delta H reactants. Delta H reaction is equal to delta H1 plus delta H2 plus delta H3 plus going on. These are the for three enthalpy change for a reaction expression we can use. In this, which one is the obvious they have given is, here they have given delta H minus product, so this one is there, but here they have given wrong. They have given reactants delta H. So delta H reaction, they have given delta H reactants minus delta H products, but here the formula for enthalpy change for a reaction expression is, we will get delta H product minus delta H reactants we will get. So here therefore it is wrong. They have given here wrong they have given. So option A it can't be. Next, delta H reactants is equal to BE products minus BE reactants. So BE products they have given. So here also wrong they have given. Next, delta H reactions is equal to delta B reactants minus B products. So here this one is correct, because B reactants minus B product only will get. So therefore option B is correct, and option D it is not. It does not comes here. It comes to S law there. There you have used this, so that's why it does not belongs to this one. So therefore option C is the correct one for this question number 37. Okay. So see, like this, we have to remember the formulas, equations, and important topics of the chapters. Of that important topics you have to remember in the whole chapter. Most important topics you have to remember. Then only you will get the answer correctly. Okay. Now another, if we after solving the question number 37. If we come to question number 38, in this they have asked, in the reaction, they have given one reaction, they have given here, that is S plus 3 by 2 O2 gives us SO3 plus 2x kilocalories, and next another equation, two equation they have given. Here they have given SO2 plus half O2 gives us SO3 plus y kilocalories, in which heat of formation of SO2 is. So heat of formation of SO2, how it will be, we will get. They are asking, option A we will get x plus y from this heat, x minus y, 2x minus y, or 2x minus y, how it will be. So if we solve, so s plus 3 by 2 O2 gives us SO3 plus 2x kilocal, and in second equation that they have given, SO2 plus half O2 gives us SO3 plus y kilocal. Now subtracting equation 2 by 1, we get, if we cancel, what all the cancels we have to do, if we cancel, then we will get S plus O2 gives us SO2 we will get. Okay, SO2 plus 2x will be left, 2x will get, minus y cal will get, minus y cal will get. So heat formation here, see here in the last what we get, 2x minus y kilocal, that we have to take. So heat formation of SO2 is equal to 2x minus y kilocal is the answer we'll get. That is so the option that is left is the last, that is the heat formation of SO2. Heat formation of SO2 we have to take. Okay, so like this you have to take the formula, you have to subtract it, the cancels here, O2 get cancels, and here SO2 SO3 gets cancelled, O2 gets cancelled, so S plus 1 O2 will be left. So S plus 1 O2 gives us SO2 plus 2x that is left, minus y will be there because it will be taken down. So therefore it is 2x minus y kilocal is the answer we will get for the that is the heat formation of SO2. Heat formation of SO2 is equal to 2x minus y kilocal. So here the option is 2x minus y. The option D is the answer for question number 38. Okay, Like this, you have to find the answers by seeing the question and by solving the problems, by solving the equations what they are given, you have to take. Okay, now let us come to question number 38. Now they have, after asking many sums, many questions, now they have asked a statement, means they have given a statement. On that basis they are asking no question. The change of enthalpy of a chemical reaction is same whether the reaction takes place in one or several steps, they have asked. So they are asking here, there is change of enthalpy of chemical reaction. The change of enthalpy of chemical reaction is same. Okay, the change of enthalpy of chemical reaction is same whether the reaction takes place, whether the reaction happens only once or in many times that we can do the reaction, many steps, by several steps we can do the reaction or not. So the statement that they have given, the change of enthalpy of chemical reaction is same whether the the reaction takes place in one or several method. In this, the reactions takes place in one or several method. This is a Hell's laws, means it comes under Hell's laws. When you read Hell's laws, there you will see this. You have learned Hell's laws. If you say, remember it, if you try to remember, there you will get that you will learn that Hell's laws of constant heat summation. In that you learn this information. So therefore, this is a statement that they have taken from the Hess law. From Hess law they have taken this statement. So therefore, now the right answers will be the Hess law is the right answer for this question. So therefore, the correct answer for question number 39, the statement they have asked is the change of enthalpy of chemical reaction is same whether the reaction takes place in one or several steps, is it is the Hess law. It comes under Hess law. So therefore, the correct option for this is option D, that is Hess law, that comes under Hess law. So therefore, it comes under Hess law. Is the So Hess law is the answer for question number 39. So therefore, you have to remember both the you have to remember equations, you have to remember formula to solve the sums, you have to remember the statements, what are the important statements while your teacher explaining that statements, you have to remember the statements so that you can solve these problems easily. Means if they ask statements, then only if to remember that easily you have to understand the statement. Okay, then only you will easily answer for the statement they have given if they ask question from. So question number 39, answer is option D, as I said. Next question is, so now question number after 39, or the next question is question number 40. So in question number 40, what they have asked is, what will be delta H for the reaction? So what will be the delta H for the reaction that they have given? That is CH2Cl2 gives C plus 2H plus 2Cl. So they are given that Be of C2H and C2Cl bond, these both bond, are 416 Kelvin per mole and 325 kilojoule per mole. Respectively, they have given this. So for they have given reaction, for that we have to find the delta H for the given reaction, and they have also given some more information that C to H bond and C and H bond and C to Cl bond, C and CH bond is 416 kilojoule per mole and C to Cl bond is 325 kilojoule per mole is the bond. And options they have given is, will get 826 kilojoule or 4482 kilojoule or 1650 kilojoule or 1855 kilojoule. So now what we have to do means delta H is equal to Ben minus Vep. So therefore 2 into BeC minus H plus 2 into BeC minus Cl. What we have to do means 2 into 416 we have got, no, plus 2 into 325 we have to do by using their formula. So therefore 1482 kilojoule per mole is the answer for the question 40. So by using this delta H is equal to BE or minus BEP formula, we have to solve this problem. So this is another formula we are using here. So remember all the formulas that we are using till now. So then only we can solve the questions if they give in NEET CET or any exams. If they give these problems, then only we can easily solve if we remember this the formulas and what till now I have said. So now so therefore as you got, the answer is 1402 kilojoule is the answer for the question number 40. Okay, so after this, so next again they have given in question 41, again they have given another reaction. They have given is delta H for the reaction. So delta H for the another reaction they have given is OF2 plus H2O plus O2 H2O gives O2 plus 2HF they have given. So therefore for this, in this they have given BEO of O2F and O2H and H2F and O double bond OR. So they have given information that BE of O2F will be, O2F bond will be 44 and O2H bond will be 111 and H2F bond will be 135 and O2O double bond will be 119 is the answer they have given. Okay, and these are the kilocalories per mole minus 1 they have given, mole they have given. For this reaction we have to find the answer, and the options they have given is option A they have given is minus 222 kilocalories, the answer we may get, or B we may get minus 88 kilocalories we may get, or C we may get minus 111 kilocalories is the answer we may get, or T minus 79 kilocalories is the answer we may get, they have asked. So as per the question, again we have to use the same formula that we have used in the back, that is Hess law. Delta H is equal to B into E or minus B into EP. So therefore 2 into 44, 2 we have to again take 2 into 44 first one, plus 2 into 11, 2 into 11 that is E or they are given, minus we have to take 119 plus 2 into 135, 2 for 119 we have to not take 2, only for the things they have given, means only for O2F, O2H and O2H and O2O bond we have to take. So not for this H2F bond. H2F bond we may not get 2, so therefore we will not take. So therefore the answer we get is, if we can solve this equation, the problem, we will get the answer as minus 79 kilocalories. So therefore the answer is minus 79 kilocalories is the answer for question number 41. So therefore option D is the answer for question number 41. Minus 79 kilocalories is the BE of the reaction that they have given. Delta H for the reaction, delta H for the reaction that they have given. Now after question number 41, now let us come to next question, question number 42. Again they have given another reactions, and it is like some problem also. So let us come to the question. So what if the what is the enthalpy change for the given reaction? So they have given the reaction. So what is the enthalpy change for the reaction? They have asked if enthalpies of formation of Al2O3 and Fe2O3 or minus 1670 kilojoule per mole is the enthalpy change for formation of Al2O3 and Fe2O3. and minus 834 kilojoule per mole. So for Al2O3 the enthalpy change is minus 1670 kilojoule per mole, and Fe2O3 the enthalpy change is minus 834 kilojoule per mole respectively. So they have given a reaction that is Fe2O3 plus 2Al gives us Al2O3 plus 2Fe. They have given. So they have asked what is the enthalpy change. They have asked for this reaction what is the enthalpy change they have asked. So option they have given is option A. Will it be minus 836 kilojoule per mole, or will it be plus 836 kilojoule per mole, or it will be minus 424 kilojoule per mole, or it will be minus 424 kilojoule per mole, or plus they have asked. So now we have to solve this. So let us solve the problem. So delta H is equal to HP minus delta HP minus delta HR is the formula. So therefore that is 1670 they have given. No, 1670 minus 834 they have given this. So therefore minus 1670 minus 834. So minus into minus plus will happen, plus into minus minus. So therefore minus is the symbol, means minus is the we will put answer. So minus 836 kilojoule per mole is the answer for question number 42, and this minus 836 kilojoule per mole for is the enthalpy change of the given reaction that they have given. For that the enthalpy change is minus 836 kilojoule per mole, and this is the option. In the option A we will get this answer, as you can see. So therefore option A is the correct answer for the question number 42. So after question number 42, now let us come to next question, that is question number 43. So now I have taken little bit speed, so let us under speed let us go, as I think you understand little bit sums now. So as some these next upcoming sums are little bit some upcoming sums are on the formulas till now what we have learnt, whether it may be S law or starting formulas what we learnt, on that only we will get these sums. So that's why. So here they have asked the enthalpy of a solution delta H, a solution of XY in the water can be determined by in the diagram that they have given. So here they have given diagram, and they have asked will we get it as delta H lactic is equal to delta H hydra plus delta H solutant, or we'll get it as delta H hydra is equal to delta H lactic plus delta H solutant, or will it be equal to delta H solutant is equal to delta H lactic plus delta H hydra and option D delta H solutant is equal to delta H lactic into delta H hydra is the options they have asked for. What will be our enthalpy of the solution that they have given. So according to Hess law, the constant heat submission, or just Hess law also you can see, we have to state that regardlessly of the multiple stages or steps of a reaction, so multiple stages or steps of a reaction, so therefore the sum of the enthalpy changes of all changes, so sum of the total enthalpy change for the reaction is the total enthalpy change of the reaction is equal to the sum of the enthalpy change of all the charges, okay, all the changes. So therefore the formula will be delta H sound is equal to delta H lactic and delta H hyd will be the formula we will get. So therefore hence the correct answer is what we will get here, this option delta H solutant is equal to delta H lactic plus delta H hydra. So in the option I think option C, on option C we will get this formula, means this option that they have given means the formula of Hess law. This is not formula of Hess law, but they have asked the formula of the total enthalpy change for the reaction is the sum of the total enthalpy change of all charges they have asked. So according to this we will get in the question on the option C is the answer we will get. So therefore let us pick option C. So therefore The correct answer for question number 43 is option C, and A, B and D are both the wrong answer. So before going to any answer, think the question what they have given, what for which law it may come. So many laws are there in thermodynamics, and many first the law of thermodynamics, second law of thermodynamics, and third law of thermodynamics that you learned, and many other still questions are there, and many other laws you have learned in your chapter when your teacher explained. So that's why, so think question deeply, so that you will get the law, which law we have to take to for getting that. Think question correctly and deeply, okay? What and don't miss any point. If you miss any point, you may get confused, okay? So that's why. Now after solving question number 43, now let us come to question number 44. So in the question number 44, they have asked which of the following is not a correct statement about enthalpy of a solution. So for enthalpy of a solution, which of the following statements that they have given, the four statements they have given, in the first is the foremost ionic compounds, the foremost ionic compound, that is delta H solvent, is positive and the dissociation process is endothermic. They have said in the first option. The second option is they are asking solubility of most of the salts increases with the increase in temperature, they are said. Next, in option C, they asked is if the lactic enthalpy is very high. If the lactic enthalpy is very high, then the dissolution of compounds become very easy. Will the lactic enthalpy is very high, then the dissolution of the compound will be becomes very easy, they have asked. So, and in option D they have asked will the enthalpy of the solution is determined by the selectivity values of the lactic enthalpy and hydration enthalpy, they have asked. So in these four options that they have asked, in these four options that they have given, which one is which option is not a correct statement, they are asking. In these statements, four statements, which one is a not correct statement, they have asked. So if the increase in lactic enthalpy, then the binding force between the molecule increases. So if there is increase in lactic enthalpy, then the binding force between the molecules it increases, and more energy. So therefore, for dissolution of that of that solution, for dissolution we have required more energy. So we require more energy for the dissolution of that any of the solution they have given. So therefore, so with the increase in lactic enthalpy, the dissolution becomes very difficult. So with the increase in the lactic enthalpy, it will be very difficult for us to take that solution. So therefore the option is option C. If the lactic enthalpy is very high, then the dissolution of a compound becomes very easy. So it is wrong, because because if the lactic enthalpy means they have said that if, as you know, if lactic enthalpy is very high, then the dissolution of compound, the lactic enthalpy is very high, the dissolution of compound becomes very easy. No, it becomes very tough, very difficult for dissolution. So therefore option C is the incorrect option that in the following three options that they have given. Now, so therefore option C is the wrong answer for question number 44. Okay. Now let us come to question number 45. So we have come to question number 45. So in question number 45, they have asked a formula. So it's a little bit big question, let us see. So they have asked a formula CaCO3 that is in solid form gives us CaCO that is also in solid form plus CO2 that is in gas form. So Next one here, another formula is delta S H naught CaO gives is equal to minus 365.1 kilojoule, and delta H naught for CO2 is equal to minus 393.5 kilojoule per mole, and delta H naught for CaCO3 is minus 1206.9 kilojoule per mole. So for this reaction that they are given, in this which of the following, means in this reaction which of the for this reaction they have given some statements, the 4 statements they have given. So in these 4 statements, which one is a correct statement for this following 4 reaction? Okay, so first statement they have given is a large amount of heat is evolved during the decomposition of CaCO3, they have said. In second statement they have given that decomposition of CaCO3 is an endothermic process and heat is provided for decomposition. For decomposition heat is provided, they have said in the second option B. In option C they have said that the amount of heat evolved cannot be calculated from the data that they have provided. From the data that they have provided, we cannot calculate the amount of heat they have heat that is evolved in that reaction. Option D they have asked is delta H naught is equal to delta FH naught, that is reactants minus delta FH naught, that is the products, is they have given. So in these 4 statements, if we see that CaCO in this CaCO3, that is solid, gives a CaCO, that is solid, plus CO2, that is gas. So delta H decomposition is equal to delta FH products minus delta H reactants. Okay, delta FH reactants. So therefore here delta FH is CaCOS plus delta FH naught, that is CO2, that is products is CO2, minus the reactant, that is CaCO3 is the reactant. So therefore that is equal to minus 635, that is the for delta H for number they have given for react, means the CaCO they have given. So minus 635.1 minus CaO2 that they have given is, for that is minus 393.5 is the number they have given for CaCO2, plus 1206.9 is the number they have given for CaCO3. So therefore delta H decomposition of CaCO3 is equal to 178.3 kilojoule mole minus 1 mole is the answer. So therefore delta H is positive. So therefore decomposition of CaCO3, so it is an endothermic reaction process, and therefore heat is provided for decomposition of this reaction. So therefore option B is an correct answer according to the question, means according to this option. So according to this statement, the correct statement in this they have given is option B is the correct statement in the following statements that they have given. So therefore the question number 45, the answer is option B. Now if we come to next question, that is of question number 46 is our next question. If you come to question number 46, here also again they have asked another reaction for that. Here they have asked what will be the heat reaction for the following reaction. So for the following reactions, what will be the heat reaction for this? So will the reaction is will be endothermic or exothermic? They are asking for the reaction Fe2O3 solid plus 3H2O. So for in this Fe2 is equal to they have given delta H2O is equal to 3 minus 285.83 kilojoule per mole, and Fe2O3 is equal to minus 824.2 kilojoule per mole is the option they are given. So therefore in the options they have given is, this is a reaction, so options they have given is option A they have given that minus 824.2 kilojoule per mole, it is an exothermic reaction. Option B plus 33.3 kilojoule per mole is an endothermic reaction. Option C minus 33.3 kilojoule per mole is an exothermic reaction. Option D plus 824.2 kilojoule per mole, it's an endothermic reaction they have asked. So by using this formula, again we have to use the same formula there, but little bit change you have to use. Here we have used 3 reactant products and decomposers, but here little bit change in the formula, that we have to use delta Fe is equal to delta FH naught, because here we have to take decomposers and products that they have given. So therefore delta H is equal to 3 minus 285.83 minus 824.2. if we do plus, so and if we do plus minus plus plus into minus, if we do, so we will get the 3 is minus, so therefore the answers if we calculate we will get as 33.3 kilojoule. So according to this reaction will be exothermic, so therefore the option C is the answer, correct answer for the, sorry, 1 minute. So option C is the correct answer for the question they have given. As I said, as you know, so option, as I here I calculation as I done, so by this calculation I am getting the correct answer is option C I am getting. So therefore we have to take let us take option C as the correct answer. So little bit, so according to question you have to see which formula we have to put. So back in this question we have put same formula, but here we have taken decomposer, products and reactant, because here they have given that 3, but here only they have given 2 options, 2 for numbers they have given. So therefore for that 2 numbers we have to take the formula which one they have given in the, when you are reading this Hess law in the and other options in the thermodynamics, that time you will see the formulas, that in that which formula we want, we have to think and we have to put. Okay, so after question number 46, now next again another reaction they have given in question number 47. So now I think the reactions have been started from for last 3 questions. The reactions, on the reaction basis they are asking the questions. So let us come to next for question 47. Here they have asked formation of ammonia is shown by the reaction. So formation of ammonia is shown by the reaction. By the reaction they have shown the formation of ammonia, that is N2G plus 3H2, that is gas, gives 2NH3 gas plus delta or H naught is equal to minus 91.8 kilojoule mole minus 1 is the reaction they have given, in which they have asked what will be the enthalpy of the reaction for the decomposition of NH3 according to this reaction. They have given another reaction here, that is 2NH gives N2 gas plus 3H2 gas. So what will be delta H? So therefore we have to find the NH3 according to this reaction. We have to find the enthalpy of the reaction for the decomposition of NH3. So option A they have given that minus 91.8 kilojoule per mole, will it be, or B 91.8 kilojoule per mole, or C it will be minus 45.9 kilojoule per mole, or D it will be 49.59 kilojoule per mole. Sorry, 45.59 kilojoule per mole. So now we have to calculate it by the given reaction what they have given. The given reaction is N2 gas plus 3H2 gas gives 2NH3 gas. So delta RH is equal to it will be we'll get 91.8 kilojoule per mole, because so 2NH3 gives us N2 plus 3H2. So delta RH is equal to minus, that is by this formula if we solve we will get minus 91.8. So therefore it will be equal to plus 91.8 kilojoule per mole. Since the reaction is reversible reaction of the above given reaction, so therefore the sign of delta H will be reversed. So therefore it is minus, it will become plus. So therefore plus 91.8 kilojoule per mole is the answer for our question, that is option B is the correct answer for 1 minute I will take. Okay, option B is the right answer for our question 47. So you have to think correctly and solve the formulas, reactions that they have given. Now let us come to 48. So here they have asked a match the following. They have asked a match the following. Here they have asked, they have given 2 columns in column 1 they have given reactions, in column 2 they have given to which it belongs, whether it will be lactic enthalpy or Hess law, or to which it belongs they have asked. So the A, let us read column 1. So A is column 1, A option is CH4 gas plus 2O2 gas gives us CO2 gas plus H2O. B they have given is H2 gas gives 2H gas, they have given option B, and option C they have given us NaCl, that is NaCl is solid, and Na plus is gas, and NaCl is gas gives us Na plus, that is aqueous, plus Cl minus, that is also in aqueous form. So after column 1, reading column 1, now let us come to column 2. Column 2 they have given the delta solution H0. Yeah, first one option they have given, and for option 2 they have given is delta lactic H0 is the option 2, and option 3 is delta CH0, and option B for option 4 they have given us delta bond H0. Now if we come to the options, they have given that option A, so A question belongs to fourth answer, and B belongs to third answer, C belongs to first answer, and D belongs to second answer. And option B they have asked, will A belongs to second answer, or will B belongs to first answer, or will C belongs to fourth answer, or will D belongs to third answer, they have asked. And option C they have given A belongs to first answer, will B belongs to second answer, will C belongs to third answer, will D belongs to fourth answer, they have asked. And option D they have asked A belongs to third answer, B belongs to fourth answer, C belongs to second answer, and D belongs to first answer, they have asked. So let us see, let us solve the problems so that we will get the answer. So let us take first reaction they have taken. CH4 gas plus 2O2 gas gives us CO2 gas plus 2H2O. So therefore it is a combustion reaction. So therefore it is a combustion reaction we'll get. So combustion reaction it is. Next option B, H2 gas gives 2H2 gas, involves bond dissociation. So therefore it is option B belongs to fourth one, because see here bond reaction is here option, here fourth one it is bond delta bond HC. So okay, next is NaCl NaClS gives Na plus plus Cl minus. So it is a dissociation of that is the NaCl. So dissociation means option 2 they have asked the lactic enthalpy, dissociation of lactic enthalpy, so therefore it belongs to that. And option D they have given NaClS gives Na plus aqueous plus Cl minus aqueous, so it shows dissolution of NaCl in water. So this shows dissolution of NaCl in water, so therefore it belongs to option 1. So therefore the right answer for the question number 48 is so let us put the right answer. So first let us correct it. So first one it belongs to option 3. So first one here we will put as A. Okay, next second reaction it belongs to option 4. So let us put here little bit big B. Next third option C, so it belongs to option second, so therefore let us put here C, and therefore the left one is here, that is D. So therefore the correct answer, now let us see, by seeing this the correct answer that we get is option D is the correct answer for the question number 48 is the so option D is the correct answer we have got. So remember this, you have to solve, means you have to think correctly which formula means which formula will it be use, which one we have to think. Okay, so after this, now after question number 48, so now let us come to our next question, that is question number 49. So here they have asked the enthalpy of the dissolution or solution. So the enthalpy, will it be a dissolution or will it become a solution of a reaction that they have given is sodium chloride. For sodium chloride they are asking, will the solution they have given will for sodium chloride, will it be dissolution or solution, will it become, they have asked. So therefore sodium chloride is 4 kilojoule per mole we will get, and its enthalpy of hydration of ions is, its enthalpy for hydration of ions will be minus 784 kilojoule per mole is the its enthalpy of ionization, enthalpy of ions, its enthalpy of hydration of ions. Okay, so therefore we have to find what is the lactic enthalpy of sodium chloride. So what is the lactic enthalpy that we get from the in the sodium chloride, what is the lactic enthalpy we get, they have asked. So in option A they have asked, will it be plus 780 kilojoule per mole, or will it be plus 394 kilojoule per mole, or plus 788 kilojoule per mole, or plus 398 kilojoule per mole. So all are plus, okay, all are positive. Okay, so now delta H solution is equal to delta H lactics plus delta H hide. So here you learnt this formula. Wait here. Wait, one minute. In question number, 1 minute, where you learnt. Yes, in this question number 43, see here you learnt this formula for Hess law. Stage reaction means the total and enthalpy change of the reaction is the sum of the enthalpy change of all changes. This formula there you learnt. So delta H solution is equal to delta H lactic plus delta H hydra. So therefore again they have asked on that base only, they have asked this question. So now delta solution they have given, for solution they have given 4 is 4 kilojoules. So sodium chloride solution, there it is a more value, its number is 4 kilojoule for mole they have given, and delta H lactic they have not given. Okay, delta H lactic they have not given, and they have given here is so delta H hydra they have given. So delta H, this they have given the ions hydration. So therefore minus 100 hydration for delta H, HYD means hydration. So minus 784 kilojoule per mole is the answer. So therefore minus 784 kilojoule per mole, plus into minus it will become so therefore plus 4 will, if we shift will be to this side, it will become minus. So therefore minus into minus plus, so therefore plus 784, so plus 788 kilojoule per mole is the answer we will get. So therefore the answer is plus 788 kilojoule per mole will get answer. So therefore the correct answer for question number 49 is the option C is the correct answer for question number 49, that is 788 kilojoule per mole is the lactic enthalpy of the solution sodium chloride. Okay, after this seeing this option, let us come to our next question after 49. Next question is, so we till now we have finished till 49 questions we have finished, and we have come to 50th question. Still 50 question is there. We have total 100 question we there, and we have still 50 questions. So I think video will be long, but still the content is more. So therefore this is very important content. It is very important for your exam. So please don't leave the video. Okay, so it's some important questions it's having. So therefore please don't leave the video and miss these important questions. You can also practice. I am not saying that just answer. First I will say question, so before saying our answer you can pause the video and you can also try to solve that. And till 90 to 100 questions, the last 10 questions I will use. I will give you 1 minute time. In that you should only see practice, and then I will say the answer in the last. After saying the 10 questions in last, saying I will answer the I will give the answer for that question. Okay, so let's come to 50th question now. Let us finish this 50th question. first. So dissociation of water takes place in two steps. They have said that dissociation of water, it takes place in just two steps. Dissociation of water takes place in two steps. That is, they have given two reactions, that is H2O gives H plus OH. For the delta H value is plus 497.8 kilojoule, and OH negative gives H2H plus O2 negative. That is delta H, for the delta H value is minus plus 428.5 kilojoule is the delta H value. So therefore, what is the bond energy of O to H bond? So O to H bond, what is its bond energy? Will get, they have asked in the question. So now, so option A, that they have given that 463.15 kilojoule is the bond energy we may get, or option B 428.5 kilojoule per mole is the bond energy we will get, or option C 69.3 kilojoule per mole is the answer we may get, or option D 926.3 kilojoule per mole is the answer we may get. They have asked in this 4 or in this, yeah, they have given. Now let us solve. So in the given the two reactions that they have given, delta H is basically representing bond energy. So delta H is, it is representing the bond energies in this two reaction, that is H2O bond that it is giving. So therefore our answer should be average of this delta H value, of this two delta H value. Our answer will be its average. So therefore now let us find the average of this bond dissociation energies. So therefore 497 plus 428.5 divided by 2 we will put. So therefore 463.15 kilojoule is the answer we will get for this question. So therefore let us see which option is the right. So by seeing, so option A we are getting 463.15 kilojoule per mole. So therefore option A is the correct answer for the question number 50 we have got. So as I said, let us discuss about this more. Let us discuss something or still. So till now we have discussed just questions. Let us discuss more. So after this, in last after this explaining this 100, I mean after solving these 100 questions from the material, I will be giving some more information to you about the this chapter also, thermodynamics, some more long questions which they may ask in your final exam, and also in final exam which they may ask for you. About that information also I will be giving you in the in the last of this after this 100 questions finish. So please don't skip any videos, as every information, you know, it's important. So you should, for solving this, as you know, for solving thermodynamics also you need formula, you need information, means you need definitions of the everything, whether it be base law, the first law of thermodynamics or second law of thermodynamics, you need explanation. So therefore don't skip anything, read what is where you have in your chapter, read it, and also you should read what are the important equations, equations you should read, important equations, important questions, that all you should read. So that's why means important formulas, that so formulas is important for solving the problems. As you know, in thermodynamics, less than definition till now you have saw more formula, means more they are asked problems. So for solving the problems you need some, means you need formulas, how so you need thinking. So remember that. So formulas, definitions, and important information what about the any topic, that all you have to remember for solving this till now. Okay, so this was what I little bit information I want to give. So as we finish the 50 questions, now 50th question, so I think we should continue now. So now 51st question. Now let us come to 51st question. They have said, so 51st question, again another sum. See, as I said, they may ask, they will ask more sums. So another sum they have asked is 50 mole of 0.1 m NaOH is added to 60 milliliter. So 50 mole 50 milliliter of 0.1 m NaOH is added to 60 milliliter of 0.15 m. So H3PO4 is the solution we get by doing this. So the pH of the mixture would be, the pH for that mixture would be about, so what is the pH for this mixture we will get, they are asking. So they have given additional information also. K1, K2, K3 for H3PO4 or 10 to the power minus 3 and 10 to the power minus 3 comma 10 to the power minus 8 and 10 to the power minus 13 is the K1, K2, K3 for this H3PO4 solution, and log 2 is equal to 0.3 is the answer for log 2. Okay. So now if we solve, so 50 milliliter of 0.1 m 1 mole of NaOH is, so it will be equal to 50 by 1000. So 50 by 1000 we will take. So 50 by 1000 is into 0.1. So therefore it will be 0.005 is the 005 moles is the answer we will get. And for 60 milliliter of 0.15 mole H3PO4 minus 60 by 1000 into 0.5, that will be equal to 0.009 mole is the answer we will get. So therefore 0.5 mole is the for NaOH and 0.9 is for H3PO4. So therefore 0.009 minus 0.005 is equal to 0.004 moles of H3PO4. So therefore pH is equal to log plus log NaH2PO4 by H3PO4. So therefore log 10 to the power minus 3 that they have given here, K for log K3, Ka we have to take 10 to the power minus 3 in that reaction they have given. So here in this additional information that they have given, so therefore 0.005 by 0.004, if we divide we will get 3.14 we will get. So therefore 3.14, so therefore 3.14. so let us see where the 3.14 option will get. So we get 3.14 in option A. So therefore option A is the correct answer for question number 51. So for question number 51 option A is the correct answer. Okay. So after this let us come to our next question, question number 52. Again another problem they have given. Here they have asked the heat of a combustion of ethane. So the heat of combustion of ethane and benzene. So heat of combustion of ethane and benzene. So for ethane they are given minus 1560 is the heat of combustion of ethane and minus 3268 kilojoule per mole is the heat of benzene. Okay. Mole. So respectively, so which of the following has higher efficiency as fuel per gram and the amount of the heat produced per gram? So how much is the amount of the heat produced per gram and fuel produced per gram they have asked. So therefore they have asked in option A benzene. If benzene has heat means how much, for 41.9 kilojoule per mole, or ethane 52 kilojoule per joule, or benzene 78 kilojoule, or ethane 30 kilojoule. So now if we solve, so heat of combustion of ethane C2H6 is equal to minus 15060 kilojoule per mole, and efficiency per gram if we take is equal to minus 1560 by 30. By 30 we have to take efficiency if we take by 30, so we will get 52 kilojoule per mole. We have to take their efficiency, molar mass is 30, their molar mass is 30 for ethane, so therefore it will be 52 kilojoule per mole. And heat of the combustion of benzene, that is C6H6 is equal to minus 3268 kilojoule per mole. So efficiency is equal to 3268.
Pawan Kumar MT.
So okay, now if we now if we say, so therefore if we solve, we'll get 41.9 kilojoule per mole. So therefore ethane has an higher efficiency, that is 52.52 kilojoule per mole. So therefore ethane is the correct answer for question number 52. So therefore ethane, that is having 52 kilojoule per kilojoule. So therefore it is the correct answer for question number 52, ethane. Okay, ethane is the correct answer for question number 52. Now let us come to our next question, that is question number 53. So here they have asked, what will be the amount of the heat evolved by burning 10 liter of methane under standard conditions? And they have given additional information also, that heats of formation of CH4, CO2 and H2O are, so CH4 is equal to minus 76.2 and CO2 is equal to minus 398.8 and minus 24, and H2O is equal to minus 241.6 kilojoule per mole respectively they have given. So therefore options they have given is A, they have given 805.8 kilojoule per mole is the amount of heat is evolved when we burn the 10 liter of methane under some standard conditions, and B is 398.8 kilojoule per mole, C is 359.7 kilojoule per mole, 640.4 kilojoule per mole. They have given D. So now let us solve the problem. So CH4 plus 2O2 gives CO2 plus 2H2O. The formula we are getting by this, CH4 is equal plus 2O2 gives CO2 plus H2O. So therefore delta HF is CO2 plus 2 delta HF H2O minus delta FCH4 plus 2 delta HF CO2. So therefore minus 398.8 for CO2, nothing will get. So H2O will get 2 into 241.6 minus 76.2 plus 2 into 0. CO2 they have not given, so 0. So therefore CO2 they have given, but again we cannot take, so therefore we can take it as 0. So therefore the answer we will get is minus 805.8 kilojoule per mole. So 22.4 liter of CH mole gives 808.8 kilojoule per mole. Therefore 22 liter 0.4 liter we have asked here, we have taken, but now we want is 10 liter of CH4. For 10 liter of CH4 we want the answer. So 805.8 by 22.4 into 10 we can take, so therefore it will be 359.73 kilojoule is the answer we will get. So therefore in 359.7 kilojoule per mole, in which option will get 359.7 kilo per joule? So option C we can see. So therefore option C is the correct answer for the question number 53. Option C is the correct answer for question number 53. Okay, so come on, so this is the correct answer for question number 53. So like this, you have to remember formula equations you have to make. So next question is question number 54. Let us see. So let us come to question number 54. So in question number 54 they have asked the amount of heat evolved when 0.50 mole of HCl is mixed with 0.30 mole of NaOH solution, and the options they have given is option A 57.1 kilojoule, option B 28.55 kilojoule, option C 11.42 kilojoule, option D 17.13 kilojoule. So let us solve this problem. So 0.50 mole of HCl is equal to 0.50 mole of H plus ions, and 0.30 mole of NaOH is equal to 0.30 mole of OH. So therefore H plus and OH, so therefore it belongs to H2O neutralization reaction. It belongs, so therefore also 0.30 mole of HCl is equal to 0.30 mole of H plus also we can write. Since OH is the limiting agent, since the OH that we have taken it is a limiting agent, here 0.30 mole of H plus reacts with 0.30 mole of OH. So 0.30 mole of H plus reacts with 0.30 mole of OH, my OH minus. So therefore heat evolved with 1 mole of H plus. So heat that is evolved with 1 plus mole of 1 heat evolved with 1 mole H plus is equal to 57.1 kilojoule is heat evolved, and therefore heat evolved with 0.30 mole of H plus is equal to 57.1 into 0.30, that is equal to 17.13 kilojoule. So therefore the answer is 17.13 kilojoule is the answer, and we can see that answer in the option D. So therefore the correct answer for question number 54 is option D is the correct answer for question number 54. So therefore we have done a calculation, and it is like a problem also. They have asked here a problem only, so we have solved that problem. Next, let us come to question number 58. 55. So here the enthalpy, they have asked the enthalpy of formation of ammonia when calculated from the following, and bond energy data is, they have given a bond energy data. There they have given that P of N to H. So they have given that PE of into H to N into N triple bond is 389 Kelvin for N to H bond. H to H bond is 435 kilojoule per mole, sorry, and N to N triple bond is 945.36 kilojoule per mole. So they have given this information. So we have to calculate the enthalpy of ammonia when we calculate, so that the following information that they have given, we have to use it. So therefore options they have given is A is equal to A, they have given minus 41.82 kilojoule per mole. B, they have given 83.64 kilojoule per mole. C, they have given minus 945.36 kilojoule per mole. D, they have given a minus 833 kilojoule per mole. So therefore let us solve this answer by using formula. So 3H2 plus N2 gives 2NH3. So therefore bond energy of reactants minus bond energy of product, by this formula we can use. So therefore half P of N triple bond N triple bond N bond, and plus 3 by 2 BE of H to H bond and 3 BE of N to H bond. So therefore half into 949, half into 945.36 here information that they have given, N to triple bond N triple bond N. So therefore plus 3 by 2 into 435 minus 3 into 389. So therefore when we solve this problem, we will get minus 41.82 kilojoule per mole as the answer will get. So therefore this answer minus 41.82 kilojoule per mole you can see in the option A. So therefore option A is the correct answer for question number 55. So for question number 55, option A is the correct answer. So like this you have to use the formulas, you have to use the reactions, you have to calculate the reactions, and you will get the answer for any question. Okay, so next question is question number 56. So here again they have given another reaction. So therefore, so here they have given a reaction. So that reaction is C solid plus O2 gas gives CO2 gas. So they have asked that what is the relation between enthalpy of reaction? What is the relationship between enthalpy of reaction delta H or enthalpy of the formation of CO2, delta HF and enthalpy of combustion of carbon, delta H comp. So delta H is smaller than delta HF, so is equal to delta H comp, or delta HF is equal to HT is equal to a delta HF is equal to delta H comp, or delta HT is equal to delta HF plus delta H comp, or delta HF is equal to 2 into delta HF. So which one is the correct? So let us solve. So since the reaction shows combustion of 1 mole of carbon, so since this reaction it shows its combustion of 1 mole of carbon, so delta H reaction is enthalpy of combustion since 1 mole of CO2 is formed. So since 1 mole of CO2 is formed, delta H is the combustion CO2 is formed. So delta H reaction is also the enthalpy of formation of CO2. So therefore delta HR is equal to delta HF is equal to delta H comp is the formula that we get. So therefore option B. So option B, sorry, right, on option B you can see. So therefore option B is the correct answer for question number 56. So now let us come to question number 57. So here again they have asked another reaction, that is for reaction, the reaction that they have given is H2 gas plus Cl2 gas gives a 2HCl, sorry. So therefore delta H is equal to minus 44 kilocalories they are given. So what is the enthalpy of decomposition of HCl? They are asking enthalpy of decomposition of HCl, they have been asked here. So option A they have given that will it be plus 44 kilocalories per mole, or will it be minus 44 kilocalorie plus mole, sorry, per mole, or minus 22 kilocalorie per mole, or plus 22 kilocalorie per mole is the formula. Which formula will it come? They have asked here. So H2 gas plus Cl2 gas gives 2HCl. So delta H is equal to minus 44 kilocalorie they have given. So 2HCl. So for getting 2HCl we need H2 gas plus Cl2 gas. So therefore it will be equal to 44 kilocalories. So therefore the enthalpy of decomposition of 2 moles of HCl is equal to 44 kilocalories. So therefore enthalpy of decomposition of HCl is equal to 44 by 2 kilocalories per mole. So therefore plus 22 kilocalories per mole is the answer. So let us see. So option D is the correct answer for. So option D is the correct answer for question number 57. So now let us come to question number 58. So here they have asked the combustion of CS and CS2 or minus 393.3 kilojoule, minus 293.7 kilojoule, and minus 1108.76 kilojoule. So what will be the heat of formation of CS2 they have asked. So option A they have given as minus 128.02 kilojoule. Option B they have given plus 970 kilojoule. Option C they have given plus 1108.7 kilojoule, or option D plus 12 kilojoule. So all are positive we can take. So C plus 2S is equal to CS2 will get. So according to here they have given C plus 2S, if we take C will get CS2. So therefore delta H is equal to delta HP minus delta HR. So therefore, so if we take, so delta HP plus delta HP minus delta HR, if we take, we will get as answer as 128.02 kilojoules here. If we take plus this both, and if we minus it with this, so we'll get, so therefore 128.02 kilojoules. So therefore the answer is option A, 120 minus 120 minus 128.02 kilojoule is the answer for question number 58. Okay. So next, let us come to next problem. Again they have given another problem. Here they have asked bond energy of some bonds. They have given the bond energy of some bonds, and Cl to Cl bond is equal to 242.8 kilojoule is the bond energy. H to H bond to Cl bond is 431.8 kilojoule per mole is the energy. O till H bond is O to H bond is 464 kilojoule per mole is the bond energy. O double bond O is equal to 442 kilojoule per mole bond energy. So they have given this bond energy now. So using this bond energy B, we have to calculate the delta H for the given reaction. So they have given this reaction, you can see here, that is 2Cl2 plus 2H2O gives H4HCl plus O2. So for this we have to find the bond energy. Option they have given, option A is 906 kilojoule per mole. Option B they have given 172.4 kilojoule per mole. Option C they have given 198.8 kilojoule per mole, and option D they have given 442 kilojoule per mole. So now let us solve the problem. So 2Cl2 plus 2H2O gives 4HCl plus O2. Okay. So from his law we have got delta H is equal to bond energy of 2 into Ci minus Ci plus 2 into 2 into OH, that is 2 bond, then minus 4 into H minus Cl plus O double bond O. So therefore 2 into 242.8 plus 4 into 464 minus 4 into 431.8 minus 442. So therefore by using this, so we will get 172.4 kilojoule per mole is the answer we will get. So let us see where we will get 172, 172.4 kilojoule per mole on option B. So therefore option B is the answer for question number 59. Now let us come to question number 60. Here they have asked How much heat is evolved if 3.2 gram of methane is burnt and if the heat of combustion of methane is minus 880 kilojoule per mole? So they have asked a simple question that how much heat is evolved when we burn 3.2 gram of methane and if the heat combustion of that methane will be minus 880 kilojoule per mole. Option they have given option A 88 kilojoule, option B 264 kilojoule, option C 176 kilojoule, option D 440 kilojoule. Now if we solve, so 16 gram of CH4 it gives us, they have, so CH4 means CH1 16 gram, C16, so 16 gram of so if as you know calculation CH4 we will get 16 grams, so 16 gram of CH4 if it will gives heat of 880 kilojoule per mole of heat it gives. So 3.2 gram of CH4 it will give 880 by 16 if we do into 3.2 if we do we will get 176 kilojoule. So therefore if we see we can see 176 kilojoule in option wait 1 minute in option 176, I mean in option C. So therefore the correct answer for question number 60 is 176 kilojoule. Now let us come to question number 61. So if we come to question number 61, here they have asked which is the correct order of bond energy. So which one is the correct order of bond energy of single, double, triple bonds between carbon atoms? So in these four options that they have given, in this which one of the bond energy is correct of that shows single, double and triple bond between the carbon atoms they have asked. So C bond that is greater than, that is smaller than C double bond C, that is smaller than C triple bond C, or option B C double bond C is smaller than C triple bond C, or triple C triple bond C is smaller than C single bond C, or C triple bond C is smaller than C single bond C, and C single bond C is smaller than C double bond C, or C triple bond C is smaller than C double bond C, and C double bond C is smaller than C single bond C. So as you know carbon has all four valence electrons, it has four valence electrons, so it easily bonds with other carbon atoms. So it has four valence electrons, so therefore it easily bonds with other carbon electrons so that it can form a long chain. So carbon atoms, they apart from single bond, carbon also forms double bonds in compounds like alkane or triple bonds in compounds like alkyne. So a carbon bond is very strong, so a carbon bond is very strong. So the carbon to carbon triple bond has dissociation energy of 348 kilojoule by mole, that is followed by a double bond with 614 kilojoule by mole, and a single bond has 839 kilojoule by mole. So the correct form is C, option D, that is C triple bond C is smaller than C double bond C, and C double bond C is smaller than C single bond C. So let us take to option D. So therefore option C is the correct answer for question number 61. Now let us come to next question, that is question number 62. Here they have asked what will be the enthalpy of combustion of carbon. So here they have asked what will be the enthalpy of combustion of carbon to produce carbon monoxide on the basis of data they have given below. To form the carbon monoxide, what is the enthalpy of combustion of carbon? On the data that they have given below, we have to use that data and we have to find. So C, that is solid, plus O2, that is gas, gives CO2 gas. So its delta H is equal to minus 393.4 kilojoule. Bande. So after question number 62, let us come to our next question, that is question number 63. So here they have again given two reactions. They have given, that is one, again they have given here graphite and diamond. They have asked, 1 minute. So sorry, 62 question number. So here, as you know, what will be the enthalpy of combustion? So 63 only, sorry, two reactions they have given. So one, it has graphite plus O2 gas, that gives CO2 gas. So delta H is equal to minus 393.7 kilojoule. Another one is C diamond, gives C graphite, delta H it is equal to minus 2.1 kilojoule. So here they have asked what quantity of diamond will give 800 kilojoule of heat on burning. So how much quantity, if we take how much quantity of diamond if we burn, we will get 800 kilojoule of heat, they have asked. So options they have given: A 24.25 gram, B 15.24 gram, C 2 gram, D 12.12 gram. So now, so let us solve. So C diamond plus O2 gas gives CO2 for us formula. So delta H, its delta H is equal to minus 393.7 plus minus 21. The for here they have given minus 21. See minus 2.1, sorry 21, I said minus 2.1. So therefore it will be equal to 395.8 kilojoule. So if 12 gram of diamond in question, they have given that if it is 12 gram of diamond gives 395 kilojoule of heat. Okay, so we have to find 800, how much? So 800 kilojoule of heat, for how much gram of diamond we will get. So therefore 800 for the 12 by 395.8 into 800, that will be equal to 24.25 gram of diamond we will get. So therefore, so this, the 12 gram we have taken from the reaction, means 12 gram of diamond only will get. So therefore the answer is A, option A, that is 24.25 gram of heat is the answer for question number 63. Now if we come to question number 64, here so here they have asked the bond dissociation energy of gaseous. So the question they have given that what is the bond dissociation energy of gaseous form that they have given is H2, Cl2 and HCl. So they have given H2 is 104. The bond dissociation energy of H2 is 104 and Cl2 is 58 and CHCl is 103 kilocalories per mole. So for by using this we have to calculate the formation of HCl gas. So what is the formation of HCl? What is the formation? How much we'll get the HCl gas? So we have to find. So option A they have given, will it be minus 75 kilocalories, or option B minus 22 kilocalories, option C minus 45 kilocalories, option D will it be none of the above. So for calculation is half H2 plus half Cl2. So half H2 plus half Cl2 gives HCl. Okay, half H2 plus half Cl2 if we take, then we will get HCl. So therefore delta HF is equal to bond energy of the reactant. So delta HF is equal to bond energy of the reactants minus bond energy of the product. So therefore half delta HP means half delta HP, that is H2, plus half delta HP Cl2 minus half HV, that is HCl. So therefore half the H2 is, here they have given is H2 is 104, and Cl2 is, in question they have given 58 minus 103. So if we calculate, we will get 52 plus 29 minus 103. So therefore minus 22 kilocalories is the answer for question number 64. So it is in the option B. So let us take option B. So therefore option B is the right answer for question number 64, means answer for question number 64. Now after question number 64, let us come to question number 65. In question number 65, they have again asked another sum. Here they have asked, they have given that bond energy. So they have asked they have given the bond energy, that is H to H, hydrogen bond, and Cl bond, and they are 430. So hydrogen bond is 430, and Cl chloride bond is 240. Sorry, Cl bond is 240 kilojoule per mole. So therefore, and delta FH for HCl is, so delta FH for HCl is minus 90 kilojoule mole, minus 1 kilojoule per mole. So therefore we have to find the bond enthalpy of the HCl. For bond enthalpy of HCl we have to find. Option A they have given that will the bond enthalpy be 245 kilojoule per mole, will it be 290 kilojoule per mole, will it be 380 kilojoule per mole, or 425 kilojoule per mole, they have asked. So now, so bond enthalpy of hydrogen and chloride bond is, we can represent the following Cl bond is H2 gives 2H, H2 gas gives 2H gas. So therefore delta H for that is plus 430 kilojoule per mole. Cl2 gas gives Cl2 gas. So therefore delta H is equal to plus 240 joule per mole. Next HCl gas gives H gas plus Cl gas. So therefore delta HCl we have to find. So for that half H2, as we have taken half H2 in the last sum, same half H2 plus half Cl2 gives HCl. So therefore minus 90 is equal to 1 by 2 into 430. So 1 by 2 into 430 plus 1 by 2 into 240 minus BE, bond energy of HCl we have to take. So therefore bond energy of HCl is equal to 215 plus 120 plus 90, that is equal to 305 plus 120 we will get. So therefore 305 plus 120 is equal to 425 kilojoule per mole is the bond energy of the hydrogen bond enthalpy of the HCl. So let us see which option is correct. So therefore, as you know, we have got 425 kilojoule So option D is the correct answer for question number 65. So for question number 65, option D is the correct answer. Now let us go to next question, that is question number 66. Here they have given a simple question. They have asked which of the following relationships is not correct. So in this formula they have asked which of the following relationships that they have given is not correct. So delta H is equal to delta E plus delta NGRT. It is correct relationship. Delta sub is equal to delta fusion plus delta H vapor. It is okay. So delta H or not is equal to delta H reactants minus delta H product, means H product, sorry. Delta H or is equal to bond energy of reactants minus bond energy or bond enthalpy of the product. In this, option C is wrong, because from Hess law, if we take delta H or is equal to delta is equal to HF naught by products minus H naught F reactants will get. But here they have given it wrong. They have given it as delta H or naught is equal to H naught F reactants minus H naught F products they have given. So therefore this one is the wrong. This one is the wrong option. So we can say. So therefore option C is wrong in question number 66. Now let us come to next question, that is question number 67. So here they have asked that the given enthalpy diagram represent which of the following reactions. So the given enthalpy diagram they have given. Here the diagram that they have given, it represents which of the following reactions it represents, they have asked. So here if you see this diagram, they have asked here total enthalpy of reactants by total enthalpy of products they have given. So enthalpy diagram of endothermic reaction, does it represent, or it represent enthalpy diagram of exothermic reaction, or it represents enthalpy diagram of reversible reaction, or it represents enthalpy diagram for non-spontaneous reaction, they have asked. So for exothermic reactions, HR is smaller than HP. So therefore in the given graph, HR is smaller than HP. So it is the enthalpy reaction diagram for exothermic reaction. So therefore it is an exothermic reaction. So it is an it is an enthalpy diagram for the exothermic reaction is the right answer. So let us see, let us take option option C. Okay, option C is the correct answer for question number 67. So for question number 67, option C is the correct answer. Now let us come to our next question. So next question, that is question number 68. Okay, so the total entropy change that is delta S total of the system and surrounding of a spontaneous process is given by. So for this delta S total, we have to find the formula. Means we have to see which formula is correct in the following four options. First one, they have given us delta S total is equal to delta S system plus delta S surroundings, where it is smaller than 0. In next option B, they have given that delta S total is equal to delta S system plus delta S surroundings, that is greater than 0. And in C, they have given that delta S system is equal to delta S total plus delta S surrounding, that is smaller than 0. So in option D, they have given that delta S surrounding is equal to delta S total plus delta S system, that is greater than 0. So according to second law of thermodynamics, if you see second law of thermodynamics, you can see there For a spontaneous process, so for any spontaneous process, the total change in entropy, for any spontaneous process, the total change in the entropy you can see is system plus surrounding should be positive. So therefore system and surrounding should be positive. So therefore here see, in this in these following diagrams, if you in these equations, if you see, only option A is correct, because option B, system is okay, positive, system and surrounding is positive, but it is lesser than 0 means it will be negative, it will become negative. Next, it if in option so hello friends, welcome to my channel. So let us come to our next question. So in the next question they have asked, which of the following statements, that is they have given it, is correct regarding to its Gibbs change, energy change. So options they have given that, option 1 they have given that if negative g, if delta g is negative, then the process is non-spontaneous. If delta g is positive, will the process be non-spontaneous? If delta g is negative, will the process be spontaneous? Or if the delta g is positive, will the process be spontaneous? Will the process be equilibrium? In this following equation, it means in this, the correct answer that we are seeing is the energy available for a system at some conditions and by which useful work can be done in Gibbs law. It is G is equal to H minus Ts is the formula for doing the work in the Gibbs law. So therefore for spontaneous process delta G is greater than 0. For non-spontaneous process delta G is smaller than 0. For equilibrium process delta G is equal to 0. It will not come. So therefore the correct answer is delta G is negative and the process is spontaneous. Okay. So therefore option C is the right answer for our question. That is, they have asked what is the Gibbs energy change, which one is the regarding to Gibbs energy change, which one is the correct answer in the following options that they have given. So now let us come to our next question, that is 70th question. So in this 70th question, if you see, they have again asked another reaction. They have said that P plus Q gives R plus S. So P plus Q gives us R plus S, they have said. So therefore the value of delta H0 is 30 kilojoule, and the value of delta S is minus 100 joule kilo per mole. At what temperature will the reaction be at equilibrium? They have asked, in which at what temperature, the temperature they have asked. So therefore they have given that the process will be equilibrium at temperature 27 degrees Celsius or 52 degrees Celsius or 30 degrees Celsius or 45 degrees Celsius. So according to this, let us come to which formula we have to use. So from Helmholtz equation, that is delta G is equal to delta H minus T and S. According to this equation, At equilibrium, delta G is equal to 0. Okay, at equilibrium, delta G is equal to 0. Next is, hence delta H is equal to delta H minus TAS is equal to 0, or 30,000 is equal to T into 100. So therefore, temperature is equal to 300 Kelvin or 27 degrees Celsius. 300 Kelvin, or we can say if we convert it into Celsius, it will get 27 degrees Celsius. So therefore, the temperature is 27 degrees Celsius, and this 27 degrees Celsius, if you see, it comes in option A. So option E is the right answer for question number 70. Okay, so 27 degrees Celsius is the temperature, and which will be the reaction be at equilibrium. Next question. Now let us come to next question, question number 71. Here they have asked, they have given for a reaction at spontaneous, they have given a temperature and the conditions. They have given some conditions for that reaction. The conditions that they have given are delta H is equal to positive and delta S is equal to negative. They have asked, will delta H be if it is delta H is positive and delta H is negative, or will delta H is negative and delta S is also negative, and if delta H is positive and delta S is negative, or will it be delta H is negative and delta S is equal to positive? How it will be, they have asked. Now let us see. So according to this, delta G is equal to delta H minus TAS. So therefore delta H it is negative and delta S is positive. Okay, if we see, so then the value then for any value of T, delta G will be negative. So for any value of T, the delta G it will become negative. So therefore the process that we are given will be a spontaneous process. So therefore, so as you got delta S is positive and delta H is negative, so let us see in which option we will get this answer. So therefore, if we, I think, so by seeing these options, we can say wait 1 minute, option D is the correct answer. Okay, according to seeing these questions. After seeing these options, so for 70, delta option D, delta H is negative and delta S is positive is the correct answer. Now let us come to our next question, that is question number 72. So here they ask which of the following reaction will be negative delta S. So in the following given reaction that they have given, 4 reactions they have given in the options, as you can see, in that they are asking which one will be the reaction where we will get delta S negative. So they have asked. So Let us see. Let us first try it, then we will see which one is the correct one, which one we can get. First let us see reactions. Okay, so first reaction is given that H2O liquid plus gives H2O gas. Okay, next one is 2SO2 gas plus O2 gas gives 2SO3 gas. 2SO3 gas is given. After this, in the next option they have given option C. There they are Cl2 gas gives 2Cl2 gas. They have given. Final option that they have given is C8CO3 gas gives CaO solid plus CO2 liquid gas. So let us solve. So if we take 2SO2 plus O2 gas, we get plus O2 gives SO2SO3 gas. So therefore, if we divide it delta Ng, we will get SO2 is minus 3, that we will get 1. Since the number of gases mole is decreased with forward reaction, minus 1. Okay, minus 1. So minus means negative. For delta S, as you know, in the last question I said delta S will be positive. But as gaseous moles is decreasing with the forward reaction, the randoms and hence delta S decreases. So hence delta S is greater than 0. It is minus 1, but still it is greater than 0. So therefore, the correct option for question number 72 is option B. That is the reaction that they have given is 2SO2 gas plus O2 gas gives 2SO3 gas. Okay. So this was the question. So option B. Okay, option B is the correct answer for question number 72. Now let us come to question number 73. So in this question, they have given a reaction is in equilibrium. They have asked if a reaction is in equilibrium at 100 degrees Celsius. At 100 degrees Celsius, if the reaction is at equilibrium, and the enthalpy change for that reaction, will be 42.6 kilojoule per mole. Is the enthalpy change of that reaction that they have given. Then what will be the value of delta S? What will be the value of the delta S of the reaction that they have given? Okay. Delta S in joule, so we have to find it in joule only. We should in other modes, in other number we should not find. So in joule only we have to find the value of that reaction delta S, or delta S value we have to find in joule only. Okay, joule or kilo per mole we have to find. Okay, options that they have given is option A, will it be 120? Delta S value will be 120 kilojoule per mole. Sorry, joule kilo per mole, or will it be 426.6.2, 373.1, or 114.2? In these four options, which one is the current we have to choose? Means we have to calculate now. So let us come to this sum. Let us solve now. Okay. So come on. So sorry, I came back. Okay. Okay. So again the same formula that we used there, because delta G is equal to delta H minus delta TS. Sorry, T delta S. Sorry. If we come at equilibrium, delta G is equal to, it will be 0. It is equal to delta H minus T, TAS. Okay. So therefore delta S is equal to delta H by T. So therefore they have given 400 degrees Celsius. If we convert it, so therefore it will come as 42,600 joule mole it will come, and divided by 373 Kelvin if we take 400 degrees Celsius. So
If you divide it, we'll get the answer as 114.2 joule kilo per mole. So this is the answer for us. So let us see in which option we have got that 114.2 joule. So yeah, see here option D is the right answer. So like this, in similar concepts they will ask, means here, as you know, till in this chapter I am in thermodynamics, I am asking 100 questions. So therefore some questions will be similar, means numbers will be different, but formula will be similar. So there they will mix it. They may give one question depending on this formula, one question depending on Hess law, or first law of thermodynamics, or second law of thermodynamics, and other question may be like explanation. Different types they may give. So therefore you should be knowing very perfectly, as I am saying from first, you should be knowing very perfectly formulas, questions, means you should be knowing perfectly formulas, and topics, important information in about the topics. You should be very much familiar about that, then only you can answer very easily. Okay, so now next question, let us come to our next question. So if we come to our next question is question number 74. Here they've asked a simple thing: which of the following process is a non-spontaneous process? They have asked. In this following process that they have given, in this four process, which one is a non-spontaneous process? They have asked. See, like they have mixed here till now. Sometimes they will ask formula, sometimes they will ask problems, sometimes they may ask little bit tough, means a little bit like explanation will be there, and also you should solve problems like that. In middle you know, you have seen the questions. So keep reading. Okay, we'll say next. See, now they have asked you the explanation. So non-spontaneous explanation, and they are asking like example. They are asking. Okay, which will become the example, which is the process in this following process, which one will be the non-spontaneous process, or which one will be the become example for non-spontaneous process. They have asked like that. So the first one they have asked is, will be the dissolution of sugar in water will become non-spontaneous process, or will be the mixing of different gases through diffusion, or precipitation of copper when zinc rod is dipped in aqueous solution of copper sulfate, or flow of heat from a cold body or to a hot body in contact. So in this 4, if you see the physical or chemical process which do not proceed by its own in a particular direction. So the physical and chemical process does not go, it does not happen on its own in any particular direction, and it also requires some outside help. It also requires an outside help for performing its work. So this is called as, this outside help that is the object needs for performing its work is called as the non-spontaneous process. Okay, so therefore the flow of heat from a cold body to a hot body, it is a non-spontaneous process, as it requires some external work. So if you touch it, not come. So therefore they need, your body need to a little bit energy to take that heat inside. Okay, so therefore it comes under non-spontaneous process. So therefore if you see, so if you see, the correct option, means the correct answer for question number 74 is option D, from cold body to a hot body in contract. Question number 75. So understand this question because it is very much big. As you can see, they have asked it's a big question. This question is okay, but they have asked some sub questions. So therefore, understanding that sub questions also is important for your answer, for getting correct answer in this question. So understanding the sub question is also important for you. So please understand the sub questions also. So therefore, you can answer. Means you can easily understand this question, and you can only solve this answer question easily. For that, you should understand this question. Now let us come to the question. In the question, they have asked that they have asked to read the following statements. The following statements that they have given regarding to spontaneity of a process. So for regarding to spontaneity of a process, they have given some information. Means they have given statements. So we have to read the statements, and we have to mark which one is the appropriate choice. So in these three choices, they have given three statements. In that, we have to say which statement is appropriate. Okay, appropriate statement. Now let us come to first statement. They have asked that when enthalpy factor is absent, when an enthalpy factor for any question, if it is absent, then the randomness factor decides spontaneity of a process. So then when there is an if there is a enthalpy factor, when enthalpy factor is absent in any of the randomness factor, will any of the randomness factor decides will the spontaneity of a process will be there or not, they have asked. So now next sub question is when next statement is when randomness factor is absent, then the enthalpy factor decides spontaneity of a process. So when the randomness factor is absent for that equation, will the spontaneity factor decides what is the process will happen? Or in the third statement, they are asked when both the factors takes place simultaneously, will the magnitude of both factor decides? So when if randomness factor and spontaneity factor, if both the process happens in the same time, will its magnitude will tell us, will it be decides as will it is spontaneity of a process or not? They have asked in options. If we come to the options, option 1 they have given that means answer. If we come option A, statement 1 and 2 are correct and statement 3 is incorrect, they have said in option 1. In option 2 means answer option B, they have given that statement 3 and 1 is correct and statement 2 is incorrect, they have said. In option 3 they have said that statement 1, 2, 3, all the three statements that they have given are correct. And if we come to option D, here they have said statement 1, 2, 3, all these three statements are incorrect. Which one? Let us see answer. Now let us come to answer. So for spontaneity process, delta G is equal to delta H minus delta T delta S. Okay, it is the formula. Okay, so now delta G is equal to delta H when delta H is equal to 0 we will get, and delta G is equal to T delta S when delta H is equal to 0. If we delta H is 0 we will get this one we have got, and delta G is equal to delta H minus T delta S when delta H is not equal to 0 and 0 is also not equal to delta S, they have said. So therefore, by seeing these three statements, by seeing these things, we can say that delta all the three statements that they have given, these all three statements are correct. They are correct. So therefore, let's come to options now. So the options that they have given is in this, which one all the three statements are correct, first or not, second or not? Option C. So option C, if you see, so option C is the 1 minute. So option C will be our right answer for this question they have asked. Now, after finishing question number 76, now they have asked a small question. In means 75. After finishing question number 75, we have come to question number 76. In this, they have asked a small question. They have asked, which of the following expression regarding to entropy is not correct? So regarding to entropy, which of the following expressions that they have given in this option, it is not correct? Option A, delta S system is equal to Q by T. Option B, delta S system is equal to delta S total plus delta S surrounding. Option C, delta S plus S initial S final minus S initial. Next, delta S total is equal to delta S system plus delta S surrounding. These are the four options, means four expressions that they have given regarding to the entropy, and which one is not correct we have to find now. Let us come to answer. Okay, so from the definition, if you see a definition of total entropy, there we can see that delta system is equal to delta S total minus delta S surrounding is the way for equation we'll get for, means it is the expression which we get if we see the explanation for this entropy, the total entropy. So now if we see these statements here, if we see here, in option B they have given that delta S system is equal to delta S total plus delta surrounding they have given. Okay, so but we have to get delta S total, sorry, delta S system is equal to delta S total minus delta S surrounding we should get. Okay, so therefore option B is the incorrect option that they in the following options that they have given, expressions that they have given regarding to the entropy.
Hawan Kumar MT.
So now question number 77. If you see this question, they again asked another problem for you. So in chemistry, in this thermodynamics chapter, they may ask you more sums. As you can see here, there are more formulas. Because thermo is a little bit science is means chemistry is related to little bit maths also. So therefore you can see some of the questions, some more problems or like sums. So you will be, means you should be very familiar with the formulas, means what are the explanation formulas that they have given in each topics in this, whether it may be thermodynamics chapter or whether it may be any chapter. You should be very thorough with that, then only you can score good marks in whether it may be Neet, CET, JEE, anything. So now come to our next problem, question number 77 that they have given the problem. Here they asked, what is the entropy change when 1 mole oxygen gas expands isothermally? So when 1 mole of oxygen gas, when it expands isothermally and reversibly, when it expands isothermally and reversibly from an initial volume, from its initial volume, when it expands volume, that is from its initial volume that they have given as initial volume from 10 liter to 100 liter at 300 Kelvin, they have given. So therefore in this option A, So in this option A, they have given will it be 19.14 kilojoule, or is the entropy change, or joule per mole, kilo per mole, or 109.12 or 29.12 or 10. So which one will be there? They have asked. So if you see this, you will remember the starting in 10 to 12, 20 questions where we have answered the questions based on this formula that we have used is minus t 2.303 n or log v1 vf by v final by initial volume, final by initial. We have answered in this around 10 to 20 questions in the starting. In that we have seen this question. So means see this formula you have seen no there. So again we have to use that formula, because here they have asked again, they have given initial and final volume they have given. See 10 liters is the initial volume they have given, and 100 liter is the final volume they have given. Okay, so VFC 100 liter and VI initial volume, volume is 10 liter, and N number of moles is 1 mole, R is equal to 8.314 joule per mole is they are given. So therefore if we solve this by using 2.303 in our log Vf minus V1, by using this formula if we solve, we will get an answer as 19.14 joule per mole. So this is the answer we will get if we try to solve this question. Now let us come to options. So in first option you can see, so option A is the right answer for question number 77. Okay, now let us come to our next question, 78. Let us come to 78 question. Okay, another question on enthalpy change only. They have asked another question. The means they have asked another problem also, you can say. So question number 28, they have asked another enthalpy is on the base of enthalpy. They have asked another problem. Here they are asking, they have given a reaction H2O that is in the form of ice, reversible and irreversible symbol they have given, so you can see. So therefore that gives H2O water. H2O water is 6.01 kilojoule per mole is the volume, is the enthalpy change for that. So the entropy change for 1 mole of ice at its melting point will be, so at its melting point what will be the enthalpy change for 1 mole of ice when it melts? At its melting point what will be its enthalpy change, they have asked. So in the options they are given, will it be 12 joule kilo per mole, or will it be 22 joule kilo per mole, or will it be 100 joule, or will it be 30 joule kilo per mole? So let us solve. So the solution in that they have given that delta H is equal to 66.01 kilojoule per mole. So therefore it is equal to 6010 joule per mole. As the melting point of ice, as you know, it is 0 degrees Celsius is the melting point of ice. So therefore if we convert it, we will get 273 Kelvin. Now we have to use the formula delta S is equal to delta H by T. Delta S is equal to delta H by T is the formula now we have to use. So while we use this formula, delta H is equal to delta H, here we got delta H is 6010 joule per mole by the temperature we have got is T is 273 Kelvin is the temperature we have got now.
So the temperature, now what we have got, if we try to solve by the temperature, we will get as delta S is equal to 22 joule per mole. So therefore, if we see in option B, it's the right answer for question number 78. Option B is the right answer, where you will get 20, where is the answer is 22 joule per kilomole is the answer I will get. Okay. Now let us come to our next question. Question number 79. We will see now question number 79. So question number 79, here they have asked at what temperature liquid water will be in equilibrium with vapor. So therefore delta H vapor is equal to the delta H vapor that they have given is 40.73 kilojoule per mole, and delta S vapor they have given is 0.109 kilojoule they have given. So therefore in this option A they have given that the answer will be 282.4 kilo, or option B 373.6 kilo, or option C 100 kilo, or 400 kilo. So if we solve the problem by the reaction that they have given is H2O liquid, so it is reversible and irreversible symbol they have given. So therefore H2O gas, H2O liquid and H2O gas, if we take, so now at the equilibrium, so in equilibrium that is delta G is equal to 0. So now from Phipps free energy change equation, if we take Phipps free energy change equation, the delta G will be equal to delta H minus T delta S. Okay, so therefore delta H is equal to T delta S if one will take, and therefore T is equal to delta H by delta S. So delta H they have given us 40.73, and delta S they have given that 0.1079. So therefore the answer we get is 373.6 kilo is the answer we will get. So therefore for this answer in the option we will search. So in the option that they are given, in the option B 373.6 kilo is the right answer for question number 79. Now let us come to our next question. So we have come to our 80th question. 80th question, they have given two columns. In column 1 they have given for the fourth option, that is state function. They have asked a state function delta H is equal to Q, delta U is equal to Q, intensive property. These four options they have given. They have given in column 2 they have given the at constant pressure, specific heat, entropy at constant volume. These are the four options they have asked in delta in the of the column 2. Okay, so if we come to column 1, the function which depends only on the initial and final state of the system is a state function. So the functions that depends on the only initial and final state of the system is a state function. Okay, it is a state function. So initial and final function. And next so therefore entropy delta S is a state function. So state function entropy, so this one is the okay. So entropy option 3 in the column 2 is the correct answer for question state function. Next is delta H is equal to Q. So therefore at constant pressure delta H is equal to delta U plus PAV, that is equal to Q. So therefore if you take we will get Q. So therefore Q means it is a constant pressure, this one. So therefore here will come question number 2. Okay, at constant pressure. Next, at constant volume, work done is 0. Delta U is equal to Q. So delta U is equal to Q minus W. So therefore W at constant, work done will be 0. So therefore work done will be 0. So therefore delta U is equal to Q. So therefore it will be option 4 at constant volume. Is the 1 minute. Okay, so leftover. So intensive property, but you will see the answer. So therefore, the property which are independent of the quantity of matter. So the property that are independent on the quantity of matter are called as intensive property. So therefore, heat is an intensive property. We will know. So therefore, specific heat is the comes the option 4. 1 minute. We will correct it. 2, 4. Okay. So this is the correct answers I have marked for question number 80. Okay. So let's come to question number 81. So question number 81. So the graph again they have asked here they have given a graph and we have to choose the correct option for this graph. So for this graph that they have given, for that we have to choose the correct option. So the graph here they are given and the options, let us come. So delta H is equal is the net heat absorbed from the surrounding, and delta H is the net heat given to the surrounding in this diagram, or delta H is positive for the reaction. Delta H is the total energy possessed by that reactants they have asked. So if we see, so since the value of delta H is negative, it shows the reaction is exothermic. So the reaction is exothermic, we can get now. And delta H is the heat given to the surrounding. So therefore delta H is the heat that is given to the surrounding. So therefore delta H is the option B. Delta H is the net heat given to the surrounding. So therefore option B is the 1 minute. Option B is the correct answer. We have got. So therefore we have to take the option B. So therefore option B is the correct answer for question number 81. So now let us come to our next question. So therefore question number 82 become, for the reaction that they have given below, the values of standard Gibbs free energy of formation of 298 Kelvin are given. So they have given in this reaction that they have given below, for that they have given the values of standard Gibbs free energy at the formation at 298 Kelvin they have given. So what is the nature of the reaction? So what will be the nature of the reaction they have asked? So therefore I2 plus H2S gives 2Hi plus S is the reaction they have given. So delta G naught Hi is equal to HI is equal to 1.8 kilojoule per mole, and delta H2S is equal to 33.8 kilojoule per mole. In the options they have asked, is it a non-spontaneous in forward direction, or it is spontaneous in forward direction, or it is spontaneous in backward direction, or it is non-spontaneous in both forward and backward directions. In this they have asked. So I2 plus H2S gives 2HI plus S. So therefore delta G naught is equal to delta G naught F products minus delta GF reactants, so minus GF reactant, sorry. So therefore if we calculate it here, the formula if that they have given, if we calculate, so therefore we will get it as 1.8 minus, so therefore we will get it as 30 point minus 30.2 kilojoule is the answer we will get. So hence the reaction is spontaneous in forward direction, we can say, as we get minus 30.2 kilojoule. So therefore so the reaction is spontaneous in the forward direction is the option answer for correct answer for correct answer for question number 82. So 82 answer, option B is the correct answer for question number 82. So next is question number 83. So again they have given question number 83. 83 they have given another question. So here in question number 83 they have given a diagram. So they have given a diagram. So in this they have asked option that X in this diagram, will X be liquid and Y be gas and P be freezing point and Q be melting point, or will B be X in the option B, X will be boiling or Y will be melting, or P will be boiling point or Q will be melting point. In option C they have given X will be fusion or V will be vaporization and P will be melting point and Q will be boiling point. In option D they have asked, will the X evaporation, X will be evaporation, V will be vaporization, F will be fusion, and Q will be the melting point, melting. So therefore, so let us see the if we come to options. So in this, the X in this, if you see in this picture, the X represents solid into liquid. So X, it represents conversion of solid into liquid. It represents as it goes high, and in this conversion of solid to liquid, temperature does not change during phase change. So during phase change in the solid to liquid, temperature does not change. And P is melting point. So P, it is the melting point of the solid. So P is the melting point, and therefore after as the P is the melting point, Y is it represents vaporization of liquid into gas. So Y represents what is the vaporization of liquid into a gas. It represents means here temperature does not change during phase change. The temperature does not change. And Q represents the boiling point of the liquid. So here Q, it represents what is the boiling point of the liquid. What will be the boiling point of the liquid? The Q represents. After this, hence by seeing this answer, we can say that the correct answer is X represents fusion, Y represents vaporization, P represents the melting point, Q represents the boiling point. So therefore these all options we can see in the option C. So therefore option C is the correct answer for question number. And so option C is the correct answer for question number 83, we can say. So now let us come to our next question, that is question number 84. So if we come to question number 84, here they have given for a reaction. So for any reaction that they have given x till y plus z. So therefore absolute entropy of x, y, z or 120 joule per mole is the absolute absolute entropy for x, and 213.8 joule kilo per mole is the entropy for y, and 197.9 joule kilo mole is the entropy for z. So therefore by seeing all this, they have asked a small question, that what will be the entropy of the change of the reaction if the temperature is 298 Kelvin and 1 atom. Temperature is 298 Kelvin and 1 atom. So will it be 291.7 kilojoule per joule kilo meter kilo? So will or 255 or 213.8 or 257.3, which one will it be, they have asked. So delta S naught is equal to delta SP naught is equal to SP naught minus S naught, or S naught P by S naught R. So therefore 213 plus, we have to do 213, we have to calculate S naught P. So therefore 213.8 of X plus 197.97 Y plus Y plus Z if we do, and then if you minus with 120, we will get answer as 291.7 kilo 7 joule kilo. That is the options. In the options in option number, if you come to see option A, in the option A they have given, so therefore option A will be the right answer for question number 84. They have given that. Okay, now so after this, let us come to next question. Next is 85th question. Here they have asked in the options, in the statements that they have given, in that we have to mark one option which is incorrect. Which one in these options, which one is the incorrect option, we have to mark it. Okay, so first one, they have given that the process in which temperature remains constant, the process in which a temperature remains constant, that process is called as isobaric process. Okay, in second option they have given that the process in which volume remains constant, it is called as isochoric process. In third option they have asked that the relations between delta H and delta E when all three reactants and products will be solid, so therefore delta H will be equal to delta E, is the third option they have given. And the fourth option they have asked is the relation between delta G, delta H and delta S. So it will be delta G is equal to delta H minus T delta S is the relations will be. In this four option, which one is an incorrect option, we have to find and we have to take a see. Okay, so as you see, the process in which temperature remains constant is called as isothermal process. But if you see in this option A, the process in which temperature remains constant, they have said it as isochoric process. So therefore this isochoric process, it is wrong, because it is isothermal process. So therefore option A is the wrong answer for in this following questions. Okay. So therefore option A is the answer for incorrect option in the following 4 options that they have given. Next, let us come to the question number 86. So if we see question number 86, here they have given 2 columns. If you see 2 columns, in column 1 they have given exothermic, spontaneous, cyclic process and equilibrium. They have given this one. So therefore in column 2 they have given delta H is equal to 0 and delta E is equal to 0. Delta G is equal to 0, delta H is negative and delta G is negative. They have asked this in the column 2. So if we see according to the Gibbs free energy change, delta G is greater than 0. So therefore it is spontaneous process. So delta G is greater than 0. So therefore it belongs to spontaneous process. So therefore delta G is smaller than 0. If delta G is smaller than 0, then it belongs to non-spontaneous process. And if delta G is equal to 0, delta G is equal to 0. So therefore it is belongs to equilibrium process. And also delta H is greater than 0. So therefore it is an endothermic process, and if delta H is smaller than 0, it comes to exothermic process. So by seeing these all options, we can say that the state functions that are given are equal to 0, and delta H is equal to 0, delta is equal to 0 for any cyclic process. So therefore the first they have given that exothermic, so it comes to option 3. Delta H is negative is the correct answer for exothermic. Next, sorry, 1 minute, I will correct it. So it is the correct is 1. Okay. So next is they have asked spontaneous. Spontaneous, it is delta G is negative. For spontaneous, delta G is negative. So option 2. Next, delta H means next is cyclic process. It is for option 1. So therefore option left is here delta G. Equilibrium delta G is equal to 0. So therefore it comes to option 4. So therefore this is the correct equation for the match following that they are given column 1 and column 2. So therefore now let us come to our next question, that is question number 87. So in 87 they have given that what will be the melting point of KCl, potassium chloride. What is its melting point, they have asked. So if enthalpy change for the reaction is 7.25 joule mole, and entropy change of 0 is 0.007 kilojoule mole, then we have to find its melting point of hydrochloric acid by the information that they have given here. And will we get answer A 180 1835.2 Kelvin, or will it be 173 Kelvin, or will it be 1035.7 Kelvin, 1285.2 Kelvin. So therefore let us solve this problem, then we will get the correct answer. The given reaction, so the reaction that they have given is KCl. So KCl is from solid to liquid we have to make. So therefore you will get there from solid to liquid KCl, potassium chloride solid. It is reversible and irreversible reaction, so therefore it will become KCl liquid also. So therefore now at equilibrium, if it is at equilibrium, so therefore delta G is equal to 0. We'll get now at equilibrium. So from the Phipps free law, free energy change equation that we got is now till now what we have used, the delta G is equal to delta H minus T delta S, this law till now that we have used. In this delta H is equal to T delta S. So now in the T delta S, H is equal to T delta S. So therefore T is equal to delta H by delta S. So therefore T is equal to delta H by delta S is the formula we'll get, and therefore if T is equal to delta H by delta S, it is equal to 7.25. 7.25 is the answer we'll get. So therefore it is equal to 0.007 is the we have to divide 7.25 by 0.007. So therefore it is equal to 1035.7 Kelvin is the answer we will get if we solve this. So therefore if we come to this problem and if we see the options here, so in this we can see, once 035, no, so 1035.7 Kelvin. In option C is the answer we can see. So therefore 1035.7 Kelvin is the answer, is the melting point of potassium chloride. Okay, so therefore the melting point for potassium chloride is 1035.7 Kelvin. Okay, now let us come to question number 88. In this question number 88, they have asked in endothermic reactions. In these endothermic reactions, the reactants that they have given, will the reactants have more energy than products? Will it have as much energy, the same energy that the products have, or will it have the lower temperature than the products, or will it have less energy than the products they have asked? So therefore let us see. So and an endothermic reaction is a reaction. So an endothermic reaction, it is a reaction in which overall energy is absorbed in a reaction. So endothermic reaction is a reaction in which overall energy is absorbed by in a non-reaction. So therefore since net energy of a reaction is given as delta H by energy of the product minus energy of the reactants. Since energy absorbed means delta H is smaller than 0, so therefore the reacting substance that has less energy compared to that of the products that we have formed. So hence the so therefore the endothermic reaction, the reactants, it has very less energy when we compare it with the product. Okay, so therefore the option D is the correct answer for question number 88. Okay, now let us come to our next question, that is question number 89. So if you see question number 89, here they have asked, when a 500 milliliter of strong acid, if we add it to if we add the same 500 milliliter of strong base, and then if temperature rises by 4.5 degrees Celsius, what will be the increase in temperature when 100 milliliter of same acid is mixed with 100 milliliter of the same base? So what is the temperature we will get? We have to calculate. Okay, by calculation we can say 9 degrees Celsius, but it is wrong. We will not get like that. So for a strong acid and strong base, when it mixed together in equal volume, the heat of the reaction, the heat of the neutralization reaction remains constant. Neutralization reaction heat remains constant, and it increase in temperature also remains constant. So therefore 5 degrees Celsius it may cause increase. So therefore it will be option B. Okay. Now if we come to question number 90, here they have asked, delta G is the net energy available to do useful work. So to do useful work, delta G is the net energy that is available for us. So and it is a measure of free energy. So it is the delta G that we have, it is a measure of free energy. Okay. If a reaction has positive enthalpy change, if that reaction have positive enthalpy change and positive entropy change, if the reaction of positive enthalpy change and positive entropy change, under what condition will the reaction be? Under which condition will the reaction be spontaneous? Okay. So as the answer, you can options you can see, delta G will be positive at lower temperature, hence reaction is spontaneous at lower temperature. Or delta G will be negative in higher temperature, and since the reaction will be spontaneous at higher temperature. Or delta G is negative at lower temperature, hence reaction is spontaneous at lower temperature. Or delta G is negative at all temperatures, and hence reaction is spontaneous at all temperature. In this, if we see, delta G is equal to delta H minus T delta S is the formula we will get. So for spontaneous reaction, if delta H is positive and delta S is equal to positive, delta S and delta H are positive, delta G will be negative. So therefore T delta S is greater than delta H. So therefore the correct answer is delta G is negative at higher temperature, hence the reaction will be spontaneous at higher temperature is the correct answer for question number 90. Okay, so last 10 questions are left, and in this, as I said in the starting, so in these 10 questions I will explain the question. I will give 1 minute time, and within 1 minute, after telling all the questions, in the final of the question I will say the answer. What is the answer for that question? I will say after the saying all these 10 questions, still 100 questions as I said there. So from 91 to 100, after saying all the question and giving 1 or 2 minutes, I will give okay, I will give 2 minutes. Okay, so if I give 2 minutes, in that if you solve, so you will be understanding easily, I can think. Okay, so therefore I will give you 1 minute, and after telling all these questions, after these 10 questions, after the finish of this 10 question, answer I will say after this finish of 10 question. Now, as I said, I will tell the question and it will give you 2 minutes. So now let us come to question then. 91st question, they have asked, if the dissolution of ammonium chloride in water is an endothermic reaction. If the dissolution of ammonium chloride in water, if ammonium chloride is dissolved in water, then this reaction is called as endothermic reaction. Yet it is a spontaneous process. if it is a if we say it is a spontaneous process, then this is due to the fact. This is due to the fact on which fact we are saying that that it is a spontaneous reaction. That ammonium chloride in water is an endothermic reaction. Dissolution of ammonium chloride in water is an endothermic reaction. So option A, if delta H is positive and delta H if it is negative, then we are saying that that it is a spontaneous process, or delta H is negative, delta S is positive, or delta H is positive, delta S is positive, and delta H is greater than T delta S, or delta H is positive and delta H is smaller than T delta S. So I'm giving you 2 minutes time, so you can take time and you can solve the question. I will be silent. Okay, let us take, I'm giving you 2 minutes. The time starts now. The time is finished, so I think you have solved the sum. I mean, you may have got the answer. And last, I will say the answer. Now, let us move to our question number 92. Next question number 92. So, question number 92, here they have asked, what will be the signs of delta H and delta S when NaOH is dissolved in water? So, what is the sign we will get when NaOH is dissolved? Sodium hydroxide is dissolved in water. What is the sign we will get? What is the sign of delta H and delta S we will get? Will in options A they have given that will it be negative and negative, or will it be positive and negative, or will it be negative and positive, or will it be positive and positive? So which sign you will get, they have asked in the question. So again I am giving you 2 minutes time and you can start this process or solving the problem. So okay. Okay, so let us come to next question. So next question is question number 93. So in question number 93, they have given a reaction, that is P plus Q is R plus S. So in this they have asked there is no change in entropy. So in this question that they have given, in this there is no change in entropy. Enthalpy change for the reaction delta H. So enthalpy change they have given for delta H, that is 12 kilojoule mole. Under the conditions, under some condition they are given, reaction will have negative value of free energy charge. So this reaction will have negative a value of free energy change. So therefore they have asked by this, will delta H that we get, will it be positive, or if delta H is negative, or if delta H is 24 kilojoule mole, or if temperature is of reaction will be high, which one is the answer we'll get for the conditions that the reaction will be negative values for free energy change that they have given. So your 2 minutes time starts now. The time is going done. I think you are done the question. Now, next question. Question number 94. For reversible reaction, for any reversible reaction, means the reaction that they have given, X gas plus 3Y gas, key reversible and irreversible 2Z gas, for the delta H is minus 40 kilojoule. So they have to find they are given standard enthalpy of X is 60, standard enthalpy of 5 is 40, and standard enthalpy of Z is 50. So therefore we have to find the temperature at which the above reaction it will be equilibrium, at which temperature it will become equilibrium we have to find. So temperature options they are given, will it become equilibrium at 273 Kelvin or at 600 Kelvin or at 500 Kelvin or 400 Kelvin options they are given. So therefore, so again I am giving you 2 minutes time, so therefore I think you understand the question. You have to find the temperature at which the reaction, it is the reaction that they have given, reversible reaction, it becomes equilibrium. Okay, so okay, your time starts now. So therefore, the time is done. Now let us come to question number 95. Here they have given that again they have given another reaction. They have given 2 K gas plus L gas gives 2 M gas. For the delta U is minus 10.5 kilojoule and delta S is minus 44.1 kilojoule per mole. We have to calculate G for the reaction and we have to predict whether the reaction is spontaneous or non-spontaneous. We have to predict, means we have to see by solving the problem this reaction. So when we solve, will we get delta G is equal to plus 0.16 kilojoule and non-spontaneous, or will we get delta G is equal to minus 0.16 kilojoule spontaneous, or will get delta G is equal to plus 26.12 kilojoule spontaneous, or will we get delta G is equal to 20 minus 26. So okay, the time is over. Let us come to next question. That is question number 95. Here they have asked a reaction. They have given 2K gas plus held gas gives 2M gas. For the delta U is 10.5 kilojoule and delta S is minus 44.1 joule kilo. So we have to calculate what is the delta G for the reaction they have given here. That reaction here, the 2K plus L gives 2M. And also we have to predict whether the reaction is spontaneous or not spontaneous. So two questions they have asked here. One, we have to find delta G, and another, will it be spontaneous or non spontaneous. Let us come to option A. So delta G is equal to 0.16 kilojoule non spontaneous, or delta G is equal to minus 0.16 kilojoule non spontaneous, or option C, delta G is equal to plus 26.12 kilojoule non spontaneous, or delta G is equal to minus 26.12 kilojoule spontaneous. So your time starts now.
ಹುಡುಕ್ತೀವಿ.
Okay, let us come to next question. Question number 96. Your time. So they have asked at 373 Kelvin, steam and water are in equilibrium. At 373 Kelvin, steam and water are in equilibrium, and delta H will be equal to 40.98 kilojoule per mole. And what will be the delta S flow conversion of water into steam? When you convert the delta S from water to steam, you have now converted it from steam to water, but now they are asking to convert it again from water to steam. So therefore H2 liquid gives H2 gas, the formula. So we have to find delta S now. Here will delta S be 109.8 joule kilo per mole, or will delta H be 31 joule kilo per mole, or will delta H be 21.98 joule kilo per mole, or will delta H be 326 joule kilo per mole? They have asked. So your time starts now. So, okay, the time is over. Next question, let us come to next question. Question number 97. Here they have asked which of the following statements, the statements that they have given. Here, the first statement, it is in this statement, which one is not correct, they have asked. Statement 1, for respond. So, for a spontaneous process, delta G must be negative is the first statement. Enthalpy, entropy, free energy, etc. or state variables. Or a spontaneous process is reversible in nature. Or option D, total of all possible kinds of energy of a system is called its internal energy. So which one is the wrong statements you have to see. So your time starts now. So next question, that is question number 98. So here they have asked at absolute zero the entropy of a pure crystal is zero. This is because of first law of thermodynamics or second law of thermodynamics or third law of thermodynamics or zeroth law of thermodynamics. So which one due to which law of thermodynamics does the an absolute zero the entropy of a pure crystal is become zero? They have asked. So okay, your time for this question starts now. So let us come to our next question. The time has finished. So question number 99. Here they asked in dynamic equilibrium condition, the reaction on both the sides occurs at the same rate. The reaction occurs on the same rate, and the mass on the both the side of the equilibrium does not undergo any change. So both the sides in the equilibrium does not take any change, and the condition can be observed only when the value of delta G is if it is -1, +1, +2 or 0, on which value we can observe the mass, both of the mass and sides both occur with same rate, and it does not go any change when we see they have asked. Okay, your time starts now. So your time is over. Let us come to our last question that they have asked. Question number 100, they have asked the equilibrium constant for a reaction is 10. They have given a question that in equilibrium constant for a reaction you have to find it is 10. And what will be the value of delta G? What will be the value of the delta G they have asked, as they have given R is equal to 8.314 joule kilo per mole and T is equal to temperature is equal to 300 Kelvin they have given. So leaving that you have to find the other temperature, other options. So okay friends, your time starts now and this is the last question. After this question I will tell you the answers for next questions. Okay, so your time starts now. So hello friends, so let us continue. So as you know, question number 91. So question number 91, as I explained, so in that delta H is smaller than 0, so therefore it is endothermic reaction. So the now delta G is equal to delta H minus T delta S. For spontaneous process, delta G is greater than 0. Therefore, delta G is equal to delta H minus T delta S greater than 0. But delta H is smaller than delta H is greater than 0. So therefore, for delta G to be negative, delta S is smaller than 0 and delta H is greater than T delta S. So therefore the correct answer is the option. Now question number 91, option C, delta H will be positive and delta S is also positive and delta H is greater than T delta S. Okay, so this is the correct answer for question number 91. Now let us come to question number 92. So now let us come to answers. So
So when NaOH is dissolved in water, heat is evolved. So when NaOH is dissolved in water, heat is evolved, and solid NaOH is converted into liquid state. So therefore when NaOH is dissolved in water, you get heat is evolved when you dissolve, and solid NaOH is converted into liquid state. So solid NaOH that is there, it is converted into liquid state. So therefore delta H is negative and delta S is equal to positive. So therefore correct answer for question number 92 is option C, and that is the delta means delta H is negative and delta S is positive is the correct answer for question number 92. Okay, so therefore for question number 92 option C is correct answer. Now let us come to question number 93. So therefore here they asked delta G is equal to delta H minus delta minus T delta S. So therefore delta H is equal to 0. They have given that delta G is equal to delta H. So therefore for negative value of delta G, delta H should be negative. So therefore if delta H is negative is the correct answer for question number 93. Option B, delta H is negative. Delta H is negative is the correct answer for question number 93. Now let us come to our next question, question number 94. So here for the reaction x plus 3y reversible and irreversible to z. So therefore here for this reaction delta S is equal to 2 into 50. So delta S is equal to 2 into 50 minus 60 plus 3 into 40. So when you convert, so therefore it is equal to minus 80 kilojoule. You will get answer when you solve. So therefore also delta G is equal to delta H minus T delta S is the another this formula we have used till now. So at equilibrium so therefore delta G is equal to 0 it will be, and hence T is equal to delta H by delta S is the formula that we use. So therefore it is equal to minus 40 into 100 minus 40 into 1000 sorry by minus 80. So therefore it is equal to 500 kilo. So therefore option C is the correct answer for question number 94, that is 500 kilo is the correct answer for question number 94. Okay, now let us come to our next question, that is question number 95. So here I have already said all the questions, so I am telling all answers now. So 2k plus L gives 2m. Okay, 2k plus L gives us 2m. They are given delta Ng is equal to 2 minus 3 is equal to 1. So the delta Ng for this is equal to 2 minus 3 is equal to minus 1. So delta H is equal to delta U plus delta Ng RT, that is equal to 10.5 into 10 to the power 3 plus minus 1 into 8.314 into 298, that is equal to 12.98 kilojoule. So therefore delta G is equal to delta H minus T delta S, that is equal to delta G is equal to 12.98 kilojoule minus 298 is the temperature they have given in the question, minus 441.1 into 10 to the power minus 3. If we solve, we will get it as is equal to 0.16 kilojoule is the answer we will get if we solve this question. Means this solution, if we solve, we get the solution as 0.16 kilojoule.
So now, so therefore, option A, 0 delta G is equal to 0 plus 0.16 kilojoule, that is non-spontaneous, is the correct answer. Is the correct answer for question number 90. So question number 95, option A is the correct answer. Okay. So therefore question number 95, the answer is option A. So let us come to our next question number 96. Let us solve this question number 96. So in the given reaction, they have given a reaction that is del H2O liquid gives H2O gas. So we have delta S vapor. So we have delta S vapor is equal to delta H vapor by TB. So therefore it is equal to 440.98 into 1000 by 373. So therefore when we solve this, it is equal to 109.8 kilo mole. So therefore it is the answer for question number 96. So therefore for question number 96, that is 109.8. So therefore 109.8 joule kilomole is the answer for question number 96. Okay. So this is the correct answer for question number 96. Let us come to our next question number 97. Let us take the answer for question number 97 now. So in question number 97, they have asked for any spontaneous process delta G is greater than 0. So therefore the variables which depends only on the initial and final state of the system, or the state variables that depends on this. So therefore enthalpy, entropy and free energy or state, they are some of the state variables of this. And a spontaneous process is not reversible in nature, as for opposite reaction to occur a force has to be applied for occurring that. So therefore the internal energy is the total of all possible kinds of energy of that system. So therefore for this question number 97, option C is the correct answer. Option C is a correct answer for question number 97. Next, let us come to question number 98. So here the answer is at an absolute zero, the entropy of a pure crystal is zero. So for at absolute zero, the entropy of a crystal is zero, because kinetic energy will also become zero. So this is the statement of third law of thermodynamics. It is the statement of third law of thermodynamics. Sorry. So therefore, for question number 98, third law of thermodynamics is the correct answer for question number 98. Now question number 99, the Gibbs free energy changes delta G. Is delta G is greater than 0, it is a non-spontaneous process. Delta G is smaller than 0, it is a non-spontaneous process. Delta G is equal to 0, it is an equilibrium process. So therefore the conditions of dynamic equilibrium can be achieved only when delta G is equal to 0. So therefore 0 is the answer for question number 99 now. So therefore the correct answer for question number 99 is option D 0. Let us come to last question, that is question number 100. So as you know, delta G is equal to minus 2.303 RT log K. So therefore it is equal to 2.303 into 8.314 into 300 log 10. So therefore it is equal to minus 5.744 kilojoule per mole is the answer for question number 100. And if you see here also I have given some of the extra questions. If you want I will zoom it and I will see, and I have given explanation about assertion also. So okay friends, this was your CT Neet material for chapter Thermodynamics. So I will see you in my next video explain another Neet material. Till then CT Neet J material. Till then take care, have a nice day, bye my dear friends.